Eso es más fácil, güey.
Shades to fill my brain, the color of information. Magnetic poles to boost your core, a virtual heart that burns inside. Burns inside. Your mind connection, a master impulse drives us all. The stories of tomorrow, collective dreams we share come true. It's another day, another time. It's another way.
Good morning, good afternoon, good time of day to everybody. Welcome to the MariaDB Server Fest November 2022 edition. My name is Kai Arne. I'm the CEO of the MariaDB Foundation, and it is my pleasure to have an audience at this MariaDB Server Fest. The last few ones have been based on virtual presentations with at most interaction over Zoom. So now the audience here, it's not the most plentiful audience, but it's an elite audience based on the speakers of this Server Fest. That is most of the speakers. Some of the speakers are still virtual. For instance, we did not want Daniel Black to travel all the way from Canberra, so we will have some virtual presenters. We will actually have quite a lot of benefit from having an audience, and that means not only does this presenter have faces to look at, but also an audience which can interrupt and pose interesting questions. So at the end of the session, I will give this microphone to whoever wishes to ask questions from the presenter. So that's the format. Without further ado, let us start with the first presentation. And that presentation is our keynote. It is by Manuel Arostegui from Wikimedia Foundation, and it started when we got a fairly, I don't know whether to use the word desperate, but definitely strong email about an upgrade from 10.3 to 10.6 not really working. So with that cliffhanger, Manuel.
Thanks, Kai. So yeah, my name is Manuel Arostegui. I work for Wikimedia Foundation. I'm part of the database team. And this presentation is going to be about how we found a bug that was sort of like a deal breaker for us because it was blocking our migration. And we needed some help, and I'm going to describe how the process was and all the steps that we took to get the bug fixed. So first, let's define what is a software bug. So Wikipedia, of course, defines a software bug as is an error, flaw, or fault in the design, development, or operation of a computer software that causes it to produce an incorrect or unexpected result or to behave in unintended ways. That's what we know about what a bug is. I like to think a bug more like this kind of thing. That kind of error that you get by the end of the day when you're almost done for the day and then a crash happens or an unexpected thing happens. And you're hoping that it's something that you did. It's a human error or you're just looking at the wrong side. And then before the end of the day, you just check the error on Google, and all you find is a very old forum in 2005 where someone has the same error and no response. And then you're like, well, maybe Google is tricking me. And then you look for the second link, and then you still get the same. And you're in a situation where you're like, okay, now I've got a problem because your expertise doesn't allow you to go further. That is, for me, a bug. And I think pretty much everyone here has probably experienced that. So before going into the bug, I would like to introduce a little bit what Wikimedia is for those that are not aware of what we do. So Wikimedia is the non-profit that is behind Wikipedia projects. Wikipedia is the most well-known project, but we have some other sister projects I will talk about in a second. We are around 700 people at the moment, and for what it's worth, we are hiring, including DBAs and SREs. All the content behind Wikipedia is obviously created by volunteers, the Wikimedia Foundation employees. We have no word of what goes into Wikipedia or the other projects. So some of the employees in their volunteer capacity, they do contribute, but the employees, we just make sure that Wikipedia is accessible for everyone. And as I was saying, Wikipedia is the most well-known project, but we also have Wikimedia Commons, which is another one is pretty well-known, which is a free media repo. And also another big one is Wikidata, which is sort of like structured data. But we have plenty of other ones, like Wikiquote is also well-known, or Wiktionary. All of those are in our infrastructure, and we take care of them as well as Wikipedia. So I'm going to go into a little bit the infrastructure we have regarding MariaDB. This is a picture from the Dallas data center. So some of the figures for Wikipedia and the other projects. First of all of our infrastructure runs with open source. We have nothing that is enterprise in production. We believe that's the way to go. And everything that we do is public. All the tasks, all the tickets that we have assigned, all the graphing, all the repos, everything can be done and can be checked in public. We obviously have some stuff that is private, like passwords, repos, and some of the tasks that are security related, they are private for obvious reasons, which we'll see that played also a role in how we were communicating with MariaDB when resolving this bug. In terms of more infrastructure side of things, for the databases, we run Debian Bullseye at the moment, and we're running MariaDB 10.4, which is what we want to migrate to 10.6. We use bare metal, and we have around 320 instances. In some cases, we run more than one MariaDB process per instance, but in the majority of cases, we have one server dedicated per instance. So that's roughly what we have in production. We have around 10,000 wikis. One wiki is normally one language, and one wiki is one database. We'll see in a second how we distribute those more or less. But to give you an example, English Wikipedia is one database, and Wikicommon is another database. We have 2 active data centers. One of them is writable, the other one is passive, but we get reads, and we have around 45 masters in total receiving writes. And then in terms of MediaWiki unique data, MediaWiki is the software Wikipedia runs in. So in terms of data, we have around 11 terabytes of metadata. We call metadata things like user emails, password hashes, options, revisions, things like that. And we call the text, the actual text that you get in Wikipedia or the other projects. And those numbers are like 35 terabytes unique. We have some other instances which are internal services that we use for like things like Fabricator, which is our ticketing systems, and theme and more internal things. So I'm talking only about MediaWiki unique data at the moment. This is an example of a topology. We use traditional master-slave replication. That is a screenshot for Orchestrator. And the way we distribute things is based on load. For example, in the corner there you see S2. We call that section 2. We have 8 sections, and each section holds a certain number of databases. For example, English Wikipedia lives in S1 and is so big and has so much traffic that we cannot share resources. So English Wikipedia, Wikicommons, and Wikidata, they are so big that we have to have resources only for them. In the case of S2, we hold other wikis that are a little bit smaller and are fine sharing servers with other ones. So we try to distribute the load based on how big the wikis are, or how big we project them to be. So this is an example of S2 where we have, I think, is Dutch Wikipedia, maybe even Polish Wikipedia, I don't remember, but something like that. We can see both data centers clearly defined, and the blue one is the active one, the one that is getting writes, and then the yellow one, which is a little cut, is the Dallas one, which is passive, but it still has reads. And now, getting into the mix a little bit, how do we do migrations Wikimedia? First of all, we have to focus on a few things first before we decide to go for a version. And those things are basically this one. Obviously, stability. We want to make sure that Wikipedia keeps up and running all the time. So we need to make sure that the version we're migrating to is stable, has no crashes, and remains up most of the time. A key point for us, given the traffic that we have, is we need to measure performance. We need to measure if there are any big regressions if we change from major version to another major version. We focus on the query optimizer to make sure that the query optimizer is not doing something unexpected. We have noticed between versions that there are some changes in the query optimizer. Some of them are okay, some of them might not be okay, so we report those. In most of the cases, we need to know that there are not going to be surprises. So the main point of measuring the query optimizer is to know what to expect. Okay, this query is going to be slow. Is it fine? You know, is this slow acceptable? Yes, no, and then we decide how to move forward. We need to make sure that MariaDB server itself performs fine. There is no new options that might have regressions in the number of IOPS or things like that. And obviously replication. We heavily rely on replication. So we need to make sure that replication thread doesn't have any major performance or regressions. We cannot really afford lag in production. So we need to make sure that the new version is not going to make us lag behind. We also take a look into the configuration changes to see if there are some options that were deprecated, removed, or new options that might be interesting for us. Obviously, normally MariaDB gives us heads up well enough when an option is going to be deprecated, so there are normally no surprises from one version to another. If there is an option that will be removed entirely in a given major version, we start playing with that one before to see what we can expect. Monitoring changes is also important for us. We monitor a bunch of metrics, and if there are some changes in, for example, the show InnoDB status metrics that we capture, we have to change the graphs accordingly so they don't stop graphing from the migration. And then an important part is the backup changes. Migrations at Wikimedia, given how big the infrastructure is and how slowly we take things to make sure that everything is stable, we can end up having 2 versions in production for months, let's say 10.4 and 10.6. So we need to make sure that the backups are working fine for both versions and that our tooling is working fine for 2 versions, because if we run into issues, it might be 10.4 or 10.6, and we should be able to recover any of them independently. So we have to test our tooling things before committing to migrate. And how do we do this procedure? So we've talked about the things that we keep in mind, but how do we go into this? So the first tests start with testing host, obviously. What we do is we make sure that the process is stable, and as I was saying, we test the new and old options. We check if the server starts fine, it stops fine, if we need to change our Puppet things, that kind of things that are not really in production, it will not be affecting. It's just like the first glance that we took at this new version. Once we are happy with that, what we do is get one of the replicas or slaves in production. We remove them from the load balancer so it doesn't receive any reads. We just clone the database. Normally we try to go for one of the big ones, probably English Wikipedia. And the reason to do that is because we're going to have more data to analyze, more traffic. So we remove that slave from production and we just let it replicate. The whole point is to see how the replication thread works. Are we getting any unexpected lag? Are we getting replication broken for any reason? So that is question.
Do you have to stop edits on Wikipedia at this point?
No. So to remove the slave from production, we just remove it from the load balancer. So people will not be able to access that server. So reads will go to all the other different servers. So this server is completely isolated. It still replicates data that comes from production, but it will not be read. So when we're happy with the replication thread, what we have to do is this same replica, which is no longer serving reads, will reply queries that we capture in production. We reply those queries into this server. To do that, we capture the traffic, we put everything, and then we measure the query optimizer. Or if there's major changes, we check if there are queries that get broken for whatever reason, syntax changes or things like that. And then once we're happy that the queries look fine, or at least we know what to expect from the optimizer, we start also testing the backups. As I was saying, we need to make sure that we can recover from both versions that will at some point live at the same time in production. So now it comes the fun part. I heard that some people test in production. Obviously, I never do that. Well, we'll do. So we need to measure how this replica is going to perform in a real environment. So we have seen that the replica is working fine. Then we start pulling into the load balancer with a small weight in case things go wrong. Let's say that 1% of the traffic will arrive to that server. So if something goes wrong, we're not going to be affecting all the users, just those that go there. And the target is to measure the load, real load. Now you're measuring reads on top of the replication thread, so you're giving it more things to analyze. We need to check how the server behaves with the spikes, and we'll see later that this was a key role. There was a key thing in the bug that we were chasing. We check the optimizer in real time as well, how slow it could be with real traffic, not with just replaying queries, but with replication and reads coming from production. And again, we check replication thread that now has more load, the reads. So we start giving more weight to this replica. Going back, I have to say that for this, when we're happy with the replica, we only pull it in the load balancer for working hours. So when we stop working, we leave that server out of the load balancer in case something happens when the DBAs are not online. Then we have to start also testing writes. Even though our environment is more read bounded, we also have plenty of writes. So we need to check how a non-critical master will be coping with the writes. The way we do this is we don't upgrade a production media wiki master, none of the Wikipedias, but we will go for one of the internal ones. If something breaks, there's less user impact, and it's mostly internal services. And we basically measure the same thing, right? No surprises here. And then it is time to upgrade Media Wiki Master and possibly bring everything down. So the way we upgrade a master is we try to pick one of the masters that are not super critical. So we will not go for English Wikipedia or Wikicommons or Wikidata. We will try to go for another one that has some quite bunch of load and see what happens, because we don't want to pick one of the less loaded masters and then find out that when we upgrade one of the loaded one, then everything is not working. So we try to make a compromise between user impact and keep testing in production. So the last one to upgrade is normally English Wikipedia or Wikidata, Wikicommons. And now the fun part is how we run into 10.6, this 10.6 bug. So to give you a little bit of a timeline, we started in February 2022. We started packaging and compiling the new MariaDB 10.6. And by March, we were pretty happy with the stability, no surprises. And we were like, okay, let's start doing some replication testing, some query replays. Everything was looking good, all nice. So by late March, 1 month after that, we were serving traffic with this host. Everything was looking good. Some strain optimizer behaviors, no surprises, happens from version to version, nothing to worry about.
Could you, as we have a live session, so what's the strange? Is it the wrong result, or is just queries taking longer time than expected?
So basically it was the optimizer picking like a different index that we would have expected, and making some of the queries slower. But no big deals, a little bit slower, but we were fine, we report them, no big deal. By April 2022, we were happy, and we were in a position where we're confident that this host could be serving traffic 24/7, even when the DBAs were not online. All good, all fine. And then May 2022, the summer was approaching, everything was nice. We were happy with 10.6, so we put more hosts in production, smooth sailing, nothing to worry about. And then the summer hit, and we got a bug. We got some strange behaviors when we were seeing spike loads. These loads were attacks. I cannot give you more information for obvious reasons, but there were attacks happening to Wikipedia, and the effect that they were having in databases where databases were getting many more connections, and the servers were frozen. The connection was never finished. The replication thread was getting behind. We couldn't even stop MariaDB. We had to kill the process. There was no other way to fix this for us. At the beginning, we thought it was just a one-time thing, but then we kept saying that with all the attacks, it was always the same pattern with 10.6 servers. So we were pretty clear, like, okay, something is wrong with the version. We cannot continue migrating. We need to do something. That something is normally bug report. We have some expertise within the team, but it was, we checked the normal things that you would check, and we were out of ideas. We didn't really know what to expect. It was beyond our knowledge. So then we were wondering what to do, because the picture was really strange. Like, we would not be able to provide any ways to reproduce this bug, which is the first thing that you have to do when you report a bug, how to reproduce. We couldn't. These attacks, we were not able to control them. We could not reproduce the attack even in a testing environment. So what else? We checked all the things that we know how to check, but then we're running out of ideas. And we could just report the bug and then hope for the best. Hope that MariaDB will see the bug, pick it up, give it priority. But it was just like hoping, and we were pretty blocked. We could not migrate to 10.6, possibly to 10.8 or other versions, because we were not sure whether the bug would be fixed in other versions. So we sent an SOS. This is more code for SOS. Who to approach? So in 2019, I met Kai in Precona Live. We had some discussions. We have been talking through email for a few different things. So I was like, yeah, we need to talk to him and see if they can help us in any way. So we sent an email saying, okay, we're blocked. We don't really know what to do. Can you help us? In no particular order, these people help us solving the bug. And then this is the process we mostly follow. When you report a bug, and you have no sort of like internal contacts, you do everything through the ticketing system, via MariaDB, Jira ticketing system. But in this case, the communication was flowing in a lot better way. I think both parties, both MariaDB and us, were very interested in getting this bug solved for obvious reasons. So we also have constant communication through Thulip, which is a MariaDB internal messaging. And we were also posting our side of things on Fabricator, which is Wikimedia's ticketing system, because as I said earlier, we try to make everything very transparent. The key thing here was that it was an attack, and we still wanted to have everything public, but we couldn't give so much information because the attackers could be, getting that information as well. So that was tricky, but I think the most important thing was for both parties to be helping each other in this world. Like, they were interested in us getting the bug fix, we were interested in having MariaDB be very stable, and both of us were, happy to make sure that this was resolved. Because the target was to have a MariaDB stable version, not only for Wikipedia, but also for all the other users out there. So the outcome was that the bug was fixed. It took a little bit like over 2 months to get everything ready. One of the reasons is that we couldn't only test things when the attacks were happening. So when Marco committed the code that was fixing it, he was like, I'm pretty sure it's fixed. And we were like, okay, we need to test it, but we cannot test the attacks, right? We kept having the attacks, and we were seeing that the version was stable. But then at some point, we were wondering whether the attack was different in any way, and we were not hitting the bug, or if the bug was really fixed. We were 99% convinced that the bug was fixed. But it took like a little bit of time to say, okay, this now is fixed. And the thing is that we have been seeing these attacks. We still have them from time to time, and the databases are working perfectly. So we're 100% convinced that it was fixed. For me personally, having the bug fix was great, but also now the bonding that we have created with MariaDB is a lot better. We already knew each other, we worked in a few things together, but this was like a mission for both of us to get something resolved. And I think this could have not been possible without open source, because everything would have been closed. The communication is probably not as well as it was when we were in the open source world. People would be able to see the bug, people would be able to report all the bugs, stack traces were public, everything was really good. And then what is next for both Wikimedia and MariaDB? So for us, we are now going to resume migrating to 10.6. We still have some blockers because we have to stop working on the normal workflow to make sure that the bug was resolved. So we need to start fixing some of the things from our side. And I think one of the key points from here, the takeaway points, is like Wikimedia and MariaDB, we're going to collaborate more in the future. And we should, I think, because we're both interested in having MariaDB as stable as it is. And I've heard that there are rumors out there that MariaDB wants to release, is working on a tool to ease migrations, to see how migrations can be improved. And obviously, I think we would be really interested in that, because as you saw, the process of migrating takes a lot of time for us. We have to hope for many things. We have to wait for many things to happen before we're committed to migrate. So I think if MariaDB is able to release something to fix and make migrations easier, then we would definitely be interested on those things. These are the technical details of the two bugs in MariaDB ticketing system, and in our ticketing system, that is also the link to see how the investigation was going through from our side. Daniel and some others also joined and helped us in our internal ticketing system. And that's pretty much everything I have. Any questions?
So, thank you, Manuel. Really, really interesting presentation. I think you can actually also ask questions within the audience. There are people who helped. So I'm here ready to hand over the microphone to whoever wishes to ask a question. And as said, you can also ask Marco or anybody. So who wishes to start?
I saw one of the very small bullet points at the end there saying you had MyLoader issues with 10.6. I'm actually the original author of MyLoader, so we might be able to help out there as well.
Do I need the microphone to answer?
No, you don't.
Yeah, I'll talk to you, but basically we're seeing some incompatibilities between 10.6 and the MyLoader version that we're using. I can also point you to the ticket, which is public, where we're investigating all the issues, and you can see the behavior we're having. So it'd be great. If
Absolutely, yeah, we are more than willing to help.
Cool.
Quick question. So regarding this bug, what data did you have? Did you have stack trace? You mentioned that.
Yeah, we provided Marco with a bunch of stock.
Okay, so we got some information. Okay.
Yeah.
I guess I have to own up to my mistake. It was my code refactoring. I think it was maybe 10.6.5 release or something like that. So it was not in the GA release, but sometime after I did some refactoring of the InnoDB buffer pool to make the memory usage more efficient. And actually my plan for 10.6 was to deprecate this, or to start deprecating the compressed row format, which I implemented several years earlier. But then it turned out that actually there are quite a few users that are using
like
it. Wikipedia was one, and then this Nextcloud or OwnCloud, I learned that they are actually using it by default since a very long time. So we had to backtrack on that, and there was some parameter that you had to explicitly say that I want to write to compressed tables. The default value for that was changed, and now we are back to the normal. So it was caused by some kind of cleanup efforts, I would say. But I think that it was very good that you were able to provide those details. I mean, it was not only the stack traces that was not enough. We needed even more like data from the buffer pool to understand what was actually going on. It was a quite delicate thing related to relocating some memory where the log objects were living. So you had to do something strange to the logs, and that was causing this hang.
Yeah. And also to answer Monty, at the beginning when we were having the bug, the only way to fix the server was to kill MariaDB. So we were we would lose the ability to provide traces. But after one of the attacks, we were like, okay, let's leave the servers as they are, and let's talk to Marco and Daniel on this to see what they need from the frozen servers. So we left the servers untouched for like a week or 10 days, whatever they needed, so we can run all the stack traces that they needed.
So basically it was totally frozen, you couldn't connect to it?
Yeah.
Okay.
So the last person answering for the audience was Marco Mäkelä. Prior to that it was Monty Widenius, and then before that Andrew Hutchings. Further questions from the audience? Andre Jelkin.
Manuel, just a remark first. If it's bug observed after this attack has had finished, so can we speak here as about a virus? It's one thing. And second, about replication more specifically, do you use parallel replication? What kind of conservative, optimistic? Yeah.
So the attacks are still going on. It's sort of like an ongoing thing now. We are very prepared in all the layers, so it is not affecting us that much. And in terms of replication, we don't use parallel replication. We use the normal, traditional one.
Why not?
We haven't had really time to test.
Okay.
Yeah.
Okay, we have some questions from the...
Okay, so Vincenzo Ciorbaru will relay some questions from the audience.
All right, so we have a question from Jean-François Gagnier. So the first question is, this is more like related, directed at Marco. Do you think that this bug might affect MySQL upstream?
No, I don't think so, even though I don't follow details of the development anymore. This was related to some re-implementation of the locking in MariaDB 10.6. So we have a few text-based read-write logs on the buffer pool pages, and the buffer pool management, there is a separate buffer pool for compressed pages, and some cleanup and refactoring related to that. It was the cause of this.
Okay, and a question from Manuel. What load balancer does Wikimedia Foundation use?
So we use an internal MediaWiki load balancer. Yeah. For internal services, we use HAProxy, but for MediaWiki, it's an internal PHP developed for MediaWiki load balancer. It's based on code.
And open source, of course.
MediaWiki is open source.
Okay. And someone from Zulip is interested in the query replay tool mechanism that you mentioned.
So it's basically a set of scripts that we capture traffic from the slow query logs. We basically capture all the queries and then replace those. It's not super fancy.
Mm-hmm. Okay.
But then you can only check like the query time. You don't check the query results.
So yeah, once we have the queries, then we check the query time, and then if we find something weird, we go dig into the optimizer and check the query results and all that. Yeah.
Oh.
It's just like a first scan.
Mm-hmm. Do you have a problems with some queries being non-deterministic, like a return, most popular word? What if there are two words exactly the same popular that you will get different answers potentially?
I haven't seen anything like that so far.
Okay.
So one question from me is, you were talking about your upgrade process initially. Now, at one point you said you measured the query optimizer. So what exactly do you measure there? Is it just the timings or memory usage, CPU usage, I/O?
So basically what I was saying is that we run a first scan and see if we have queries that are taking longer than they should take, and then if they are, then we go and check the optimizer and see if there's something like obviously weird doing, like picking the wrong index or things like that, and then we try to run those in more servers just in case it was a stats problem, and then if we see something like very strange, we do report that, saying okay, this index makes no sense, or it's not picking whatever thing it is, and then we report those. Yeah.
So when you upgrade to newer MariaDB versions, we introduce new functionality in the optimizer. Like for example, we have better histograms, I think in 10.5. 10.8, okay. But we did introduce histograms from 10.1, and those require extra commands to be run. Do you introduce this as part of your upgrade process to try and test out and see how they...
If we can, yeah, we try. Yeah.
Okay. And I also found it interesting that you're playing with Fire process. It seems like a lot of it can be automated. Do you have automation scripts you've done? Any of those can become public, maybe help others when they try to do A/B testing?
So we have a set of a bunch of scripts that we have written just for this. One of the problems we have is that we need more people in the team. That's why we're hiring, and we need more automation. Yeah. Mm. Once we have everything, yeah, obviously it will be public. I think some of them might be public in one of the repos. Yeah.
So when it came to tracking down the bug, what do you think were the key metrics or data points you needed to gather to be able to have as good of an overview of what's happening? So I know you're tracking let's say CPU metrics, I/O and stuff. We use that during our debugging session. But can you do an overview of what you would consider to be the key items to monitor overall for a DBA, for example?
But you mean for this specific bug or in general?
No, in general, what you would recommend using Wikimedia's knowledge?
So one of the key things that we monitor is I/O weight, especially when we change version or we change hardware to make sure that the I/O weight is not going over the top for whatever reason. We also measure a lot like replication lag. Replication lag is very important for us. And then we also check how many queries are doing full scans and if they are slow, because for us that could be like killing our performance. So that's mostly what we keep in mind when we migrate.
Okay, and what about backups? Do you have any best practices for taking backups and restoring from backups?
So we have now Jaime working on the backup systems, and what we're doing the migrations. I don't know whether your question is related to migrations or...
let's say any useful information that the audience could benefit. I'm interested to hear about it.
So the backups in like a big shot, we take logical backups and we take binary backups, and we need to make sure that we can restore both of them when we migrate versions. Not only logical, because those are easy to restore when you change versions, but we're also interested in restoring binary backups because those are faster normally. So that's why making sure that we can restore both versions at the same time and the tooling work for both versions is important for us, to have the ability to say, okay, imagine that you have migrated 50% of your infrastructure. Now you're in a position where you cannot really deprecate the tooling for 10.4 because you still have 50% of the infrastructure running 10.4. and you cannot start testing 10.6 because you already have 50%. So you have to make sure that both work at the same time. In case, for example, you have to go back to 10.4 for whatever reason across the whole infrastructure. We don't want to be locked until we are locked. So we need to have the ability to go back at any time.
Okay, makes sense, makes sense. Any more questions from the audience?
I have a preparation for my talk. So for your complex queries, how many tables do you think that you have in those?
How many tables?
You have in your more complex queries? Do you have 8 tables, 20 tables?
That we join?
Yeah.
No, I wouldn't be able to tell now. But at the same time,
yeah.
I don't think we have 8, no.
Yeah. So
no,
4 or 5?
Yeah, more, something like that, yeah.
Thank you. Are we ready for the following presentation? So then, thank you, Manuel. Really interesting.
Thanks.
Now we have a pause. You can be your ugly self.
Electric shades to fill my brain, the color of information. Magnetic poles to boost your core, a virtual heart that burns inside. Burns inside. A higher mind connection, a master impulse drives us all. The stories of tomorrow, collective dreams we share control. It's another day, another time. It's another way to work things out. Getting ready to live in the cloud age. Whoa, whoa. Getting ready to live in the cloud age. Whoa, whoa. Are you ready to live in the cloud age? Whoa, whoa. Are you ready to live in the cloud age?
Eso es más fácil.
Electric shades to fill my brain, the color of information. Magnetic Electric shades to fill my brain, the color of information. Magnetic poles to boost your core, a virtual heart that burns inside. Burns inside. A higher mind connection, a master impulse drives us all. The stories of tomorrow, collective dreams we share control. It's another day, another time. It's another way to work things out. Getting ready to live in a cloud age.
So here I'm back. Sorry for the delay. We are a bit challenged. Our plan was for now to have a virtual speaker, Federico Razzoli. That didn't work out, and we still do not exactly know why, to be in the interest of full disclosure. So what we're doing is we're rescheduling a bit, and we will now get Monty Widenius to present about optimizer changes in MariaDB 11. And just to set the stage and steal a bit of thunder from Monty, he says that from 100 queries, you would probably be affected in 10 out of the cases you would get a better result or a different result. But I will leave again the audience with a cliffhanger. Monty, please.
So, despite Kai's try to steal the thunder, we will continue. So this is a talk about what I've been doing during basically the last year. And so here is a short overview of my talk. And I will not try to say what's on the slides. I will try to talk around those. So you can read them now. You can get a look at the slides later through YouTube. And if you look at the presentation later, you even will have subtitles which make my English a little bit easier to understand. So starting with the background. So in September last year, I decided that we have some issues with selectivity that needs to be fixed. Our optimizer team needed more resources, and I thought that I wrote the initial one, so some things can be blamed on me. So let's try to get this done. And I actually hadn't looked at the selectivity code, so let's try to fix it. So the issue was that sometimes the selectivity was that the optimizer created was bigger than 0, which basically means that you can trust it, you get wrong results. But while fixing it, I noticed that there's lots of things in the optimizer that has been changed over the years. Lots of good things done here and here and here, but the integration of those left something to be desired, and it was time to fix it. And almost 1 year later, I noticed that most of the bugs are fixed, but I still can't get the cost to work, so to get the optimizer to choose the right plan, so something has to be done. So I had changed all the costs to be in milliseconds instead of basically approximate over I/O. And that has helped me tremendously of getting things to complete, and basically this task was completed yesterday. And it's about 60 commits, some very big ones, and everything is available and hopefully will be in MariaDB 11.0 sometimes next week, but more about later. So the intention of the optimizer, and especially this change, is to find the best table combination and best access plan. Table combinations that if you have three or four tables, in which order should the join be done. I also worked on replacing lots of cost-based rules, logical rules to be cost-based. There is also options for end users to tune the optimizer cost if something would be wrong related to the hardware they are using. For example, if they're using a memory file system, then costs are totally different compared to a hard disk one, and so on. All costs when you do a last query result, or you can optimize a trace, I know in microseconds. So it's very easy to see that does the optimizer know what it's doing. You do a query, and the query time should be roughly the cost. MariaDB trace was added by Petrunia in 10.4, and without this tool, I couldn't have done this. So I'm really grateful that we had this one. I was a little bit unsure that when he started that how useful could this be, and I'm happy to see that it's probably one of the best tools for developers to work on the optimizer and see what is going on. And as part of this project, I added a lot of more information to the trace to be able to see the query cost and the planning in detail. So now I will go through basically all the major commits that is in the new tree. The first one was what I started with was that if you use condition selectivity 4, which means that try to use all selectivity information you have from histograms and other sources like you get from Analyze. In some cases, selectivity becomes bigger than 1, and the plans are suddenly really, really bad because the optimizer actually thinks that we will get more results from a table than there is rows in the table. And if you're using something less than 11.0 and you have an issue with bad plans, you should set condition selectivity to 1, and that goes back how things was in 10.5. As far as I know, all calculations are fixed. They are searched to ensure that it never becomes bigger than 1. I have done extensive checks of all queries that has changed in this new optimizer trees, and there is thousands of queries that has changed. Not much, but still some costs, some rows, and so. And everything looks really, really good. But as part of this change, I also did a major benefit for the optimizers, that when we go through a table and go through all the indexes and try to see which index to use. Sometimes we are using filtering, sometimes not, but we know we remember the smallest number of rows that we see to any combination. For example, there's a filter that is very selective, but also takes a very long time to execute. But that still tells us that in this where clause, there only will be 10 rows. We will use that, we didn't use that before. And that allows the optimizer now to do much better decisions than ever before. So that was an insight while working on this that actually helps a lot. Some other optimizations that are useful is that I noticed that when we do derived tables as part of a subquery, we are creating a key for be able to use the temporary table efficient, but it's, for example, here is where A in select. it's much better to create a unique key than a normal key for the subquery, which we didn't do. No, we do that, and that means that all plans are changing who are using this derived table from using a ref, which means that go and try to find all rows with this number to eqref, which actually makes things both faster and easier to understand. So the cost calculations for most things has changed to be in smaller parts. So instead of just trying to assume that reading one row, that's one disk read, reading one key, that's one disk read, doing some access or the where clause, that's a fifth of a disk read. So when we had no searching or accessing cost through time, it was harder to get the cost correct, but it's much easier to verify those and actually get something that, that is close to reality. So the consequence of the cost calculations is that we are much more likely to use an index, we are going to use filters more, materializations will happen less because the cost is actually higher than we expected it to be. There were also costs in index for group by, which is something we can do for group by optimizations. But one of the big changes is that before we assumed that the disk access cost was on a hard disk. Most people don't run productions with hard disk anymore. So all cost calculations in the server is now based on the speed of SSD. You can actually change that, just change the one variable, but about that later. And we also have to assume that all rows, read rows are cached, because I thought I was ready with the optimizer 3 weeks ago. And then I started to do some testing for some performance queries and noticed that the cost calculation didn't match reality at all. And if you imagine that you have one table that has 1 million rows, and then we're going to do a read in a table that has one row. We're not going to do 1 million disk accesses for the table with one row, because that will be cached. But that's what the optimizer thought. So that's now fixed. And we get sensible queries for that. So internally, what has happened is that instead of having just one row access, one cost, is that I have split the cost into 12 different variables, where the disk read cost is the high one, and then you have for reading a key or copying a block or copying a key or copying a row, each of the different costs. There's a program that's a part of the server who allows you to check the cost, and all the cost calculations, how I come to these numbers, is in docs optimizer cost. So all the calculations is clearly explained how we come to this. And on the SQL level, so every engine has their own costs, and you can change anything of those. And then you have some SQL level cost that you can then also affect things. So these are the user levels, and these are per engine. So these are basically global, these are local. And here is an example of running check cost, where we check that does the area engine, does the cost match actually the expectations. So it does you can run 10 different tests, starting with table scan, then key lookup, index scan, everything else. And the first row shows what happened when for table scan, and then you can see the results at the end. And as you can see, all the costs divided by time, they're very close to 1, which means that the optimizer was able to figure out exactly the time of the query. And this is run with a table with 1 million rows, and you do that for all engines, because that means that for a smaller table, probably the cost calculation will be a little bit too much, but that I'm trying to optimize that. We shouldn't do the mistakes with big tables, because with small tables, if the optimizer does some mistakes, who cares? The time is fast enough. But when you start to go into million rows, things start to matter. And We have two slides for the technical part of the audience. Sorry, Kai. And that shows how things are read up. So we have key read time, where basically is the virtual handler that storage engine can override. That should tell us how many blocks are we going to use for reading this index, and then we calculate that the total cost is the time and range times key lookup cost, and then key next find for all the rows, remaining rows. And then we also add, when we do the final cost, is that we also add key copy cost and where cost. Where cost is the time to execute the where clause. And then we have the full cost for index lookup. And for doing a row lookup, we basically do the same thing. First, try to calculate the cost of reading a block, and then calculate the cost of actually accessing the data. And this function is just there to show that reading a block, there's a factor of how many blocks, that's the blocks read, and then what's the CPU cost of doing that. Okay, so as part of the project, I changed a lot of rule-based to be cost-based, and here is everything that is related to this one. The goal is to remove all rule-based things from the server, because usually those things are bad because it doesn't take into account the execution time. For example, we had rule-based that if it's a cluster index, we should do this. If it's a covering index, in other words, we can solve the thing with the cover index, we should do this. All these ifs are gone, and instead we just calculate the cost of each version and then compare the costs. We also had some issues with, or actually, the second one is the worst rule that we had in the optimizer. It kind of works, and I think it was done for satisfy some benchmarks. Basically, is that if you have a key who has all elements are the same, and you have 1 million rows, then of course, if you're going to use that key, we are going to access 1 million rows. But in the code, we had that if we would use more than 10% of the table, then we will cap it there, which means that we will use this index for doing range scans when it doesn't make any sense, because table scans will be more than 10 times faster. Actually, it will be 20 times faster. And having cost base, we don't need that anymore. There was a really old bug in InnoDB that when we asked the InnoDB that how many rows is there in this range. If the range was more than 50%, it's a basic answer, it's only half of the rows. And I think that Marco can probably correct me, I think that's something from Heikki Tuuri's time, where he didn't like some of the decisions in the optimizer in MySQL, and that was MySQL time, so we decided, let's cap the things in InnoDB, because then the optimizer will do the right thing. But now when we actually want to do the correct thing, to be able to say that, now we have a range scan, when should we use the index, or when should we use a table scan, we need actually the exact numbers as possible. And we also had some problem with aggregate distinct. Basically, if you do a sum on distinct and value, where the things was rule-based and didn't always work, now they're cost-based. I did a lot of small improvements for the optimizer, especially with row ID filters, where the code was something that I didn't want to talk about in the public, because I still get upset looking at the code. It wasn't as good as it should be in MariaDB. We do much more caching. I added much more code comment, because lots of people worked on optimizer and lots of things was not commented. and I was spending a lot of time with Petrunia and others to understand the code and adding those. We also have tried to use longer keys when it makes sense, because in the first place with the where the optimizer sometimes would do a ref on the first key part, and because it has the same cost as the range of everything. But the range actually has more information, so it will use that one. I had to add optimizer scan setup cost that is used for table scan, because our MTR test suite uses very, very small tables. And in the end, if I wouldn't have done that, everything would be table scan and we wouldn't be able to test anything. So the most important optimizer costs that people may want to change or know about are these. So when assuming that we have to read a block, we will take the optimizer discrete cost times the read ratio, and ratio will tell us what's the chance of the block being in the cache and using those. So if one is using a hard disk, you only have to change the discrete cost to be the speed of a hard disk. And you can use scan setup cost to if you want to avoid scans. And all these are in microseconds, because even if the cost internally is in microseconds, is that the microseconds would be so small it would be very, very hard to read. So there's a factor between what the user uses and the server uses with a factor of 1,000. So for example, assuming that the optimizer has a wrong optimization somewhere and produce a wrong plan, and you want to force the optimizer to use the plan that has the least amount of rows, you can just increase the wear cost that is added to each accepted rows, and then you get the smallest possible access to rows. But hopefully that shouldn't be needed. Everything can be changed. All the SQL level costs are session variables. If you want to change InnoDB discrete cost, you can just do that. You can have those in config files. Normally, you never had to change those. But the issue is that, assuming that Wikimedia would have an issue that optimizer does something wrong in the performance testing, you can probably tell them to just change one of the variables and things will be good. So you don't have to do recompile everything else. And the formulas are pretty easy and easy to understand, so I don't expect anything that is unchangeable. So the new optimizer should be better for most things. And I don't expect there will be lots of queries that actually change to the worse. Hopefully always to be better, assuming that costs are calculated correctly. But they can easily be changed. So the question is that all these changes that I've been working on for 1 year, when does it matter to you? When should you think about using this? Is this something that should be interesting for Wikimedia? And looking at how the query optimizer was discussed several times in the last talk, I would say that this should be highly beneficial for Wikimedia. If you're just using a couple of tables, small tables, just using join a couple of those, it probably will be fine. You will not see any difference between the old optimizer and the new because this only affects when you have lots of tables or lots of data. But these are the main things where you get a benefit. And we had the 10% that I mentioned earlier. For example, you had key between 1 and 1,000 and you have 2,000 rows. That's half of the data. You should never use that key. MariaDB up to 11 will use the wrong key. So complex queries, mixing storage engines, the optimizer actually knows that in most cases the memory engine is about 3 times faster on InnoDB. It's 10 times faster with table scans, 3 times faster on indexes when everything is in memory. You probably don't need force index anymore because the optimizer should be able to figure out. You can still use it. And in some cases where the histograms could make plans worse, that was because of the problem with selectivity. And because that's fixed, MLU's table should work good. So state of things. I finished all known things yesterday, so now it's time for users to start testing it. We will still do some performance testing just to verify all the queries. There's a branch that has a very, very strange name. You don't have to remember it, but it's because things will change next week. It's still up to discussion if it will be 11.0 or not, but because this is one of the biggest changes in the optimizer and in almost 10 years, and I can't guarantee that everything will be better. I expect everything to be better. So it still needs to have a little bit of testing, and I hope we can work with Wikimedia to use the infrastructure to test this. And of course, I have got lots of ideas of future things to improve in the optimizer, as I now had time to see what happened during the last 20 years on it. So, lots of things really, really good, but something still needs to be improved. And at last, some thanks to Petrunia, who has been here helping me with the optimizer trace and doing reviews and explain to me when I'm having to understand some of the new delicacies in the new code. And Vincenzo helped me with the cost calculation for file sort, and Andrew, who helped me get column store close to complete to work with the new things. And for storage engine writers, you basically have to add one function to your storage engine to tell about the cost. If you don't do, we will assume that you have cost that is similar to area. In other words, a normal engine that can do keylookups and doesn't have a clustered index. If you have a clustered index, you need to copy a couple of rows from DB and maybe run the check cost program to check that are your costs correctly calculated. And there are documents to see how I calculate everything. So adding a storage engine to get proper cost is half an hour of work, hopefully. So that's that.
Thank you, Monty. So now there's 15 minutes time for questions, either by you to the audience or by the audience to you. And I will start by asking this thunder question again. So is it a fair estimate that out of 100 queries, let's say 10 will be affected, because you said that most of the smaller queries won't see a change. So roughly 10 would be affected, and hopefully 9 out of those 10 would be improved.
Let's say this way, I think there is 20,000 queries in that test suite, roughly, really rough estimate. And some thousand had changed, but usually it was just explained because we have statistics on part of it, and some of the statistics was wrong before, so that corrected. If you look at query plan changes, some couple of hundreds, and I went through almost every single one of those, and they are better now. At least in the test suite, there's not a single one who's worse.
So then it was hinted at both Monty's presentation and Manuel's that there is an ongoing idea for some optimizer testing, so comparing two releases of MariaDB with each other. So let's briefly say something about that idea, and I'm then asking Manuel what you think about it. So it would be a possibility to do lightweight, as lightweight as possible testing of the of a slave. So you could in your cluster add another slave which gets the same queries as the slave that is being compared to. So you would, in that scenario that Manuel had comparing 10.4 and 10.6, there would have been into the normal 10.4 cluster added a 10.6 node, and then measurements taken in parallel on those two, and without sort of having to do the same type level of fire type testing that could have been tested. So that's the idea that we are pursuing. We're still not announcing anything, but we're pursuing an idea. So I'd like to hear a comment by Manuel, both on what Monty said and how you would go about gaining the confidence in sometimes taking that release into use.
Yeah, talking about the tool that you're describing, that's probably going to help us a lot because it will simplify the whole process I was explaining before. And then the talk about Monty, yeah, we do. I'm seeing some of the things that you're mentioning there. Like, for example, if you have had to use force index to get a good plan, that is the case that we have in code in a bunch of places. So
I'm very interested to see that can we now remove those, because if my cost calculations is correct, then none of those will be needed.
Yeah, that's why I'm interested in checking this out in our environment, in a control, obviously, in a control situation, to see how of the bugs that we reported with the optimizer, if they get fixed, and we can go ahead and remove those force index or use index that we have in code.
Yeah.
Thank you, Manuel. I would like to give the word to Sergei Petrunya, just your sort of overview of this, since you've been reviewing the code and like your level of excitement, your commentary.
You're not only reviewing, he actually been working on it also. So,
well, first, I would like to make a comment that Monty said I edit optimizer trace. I was the code reviewer and I pushed for that feature, but actual coding was done by Varun Gupta.
Okay, I missed that.
And we can also thank Sergei Krivanos for the assertion you get every time you try to write invalid JSON into the trace. Yep. So the original question was...
well, your overall, that was part of your overall commentary, but your overall commentary about your level of excitement of
well, I'm excited about the costs, because previously the costs were like meaningless numbers. So when there was a query plan and you get this cost, which is costs like, well, like several thousand, like is this number? It was totally unclear whether this number had any meaning. But it was too high, too low. Well, it was good enough so that plans could be compared with each other. But now, since we got this, the cost which can be verified, which has some relationship with, or should have at least have some relationship with reality, it's going to be much more directed. There will be much more. We'll be able to reason about the query plan in much better way.
So Monty, I have a question. You had these, I think it was about 6 values where you compared the estimated cost with the actual cost, and I thought that was really, really close to 1. I mean, and do you expect that to be the case in general?
Okay. So it, of course, it depends on the CPU and everything else. So this is my desktop is actually a high-end one. So I do expect that things will not be exact microsecond, but it will be proportional correct also on other both laptops and higher machines. As long as the proportions is correct, we are fine. And it's and of course it also depends on the table size and everything else. So this is the first version, and it's more than expected good now.
Sorry.
For well-tuned queries, like typical LTP workload where every condition matters, that we should have a close match. Sometimes you wouldn't have a close match. For example, if you are looking, for taking users, and then you are interested in only users in Finland, and then joining to what orders they have. If the optimizer has no clue about which fraction of your users reside in Finland, then it wouldn't, of course, know how much. The cost number for table orders would be taken for everyone in the whole user base, not just in Finland. So in that case, you will inevitably see the discrepancy. But this is the case for every optimizer, and you will at least be able to see, like for well-tuned queries where every condition counts and every condition is used. There should be a close match. Sometimes there wouldn't be, so we don't. It's not a catastrophe or something, or a bug if you see mismatch between costs. But still there will be cases where there will be a mismatch.
And Actually, there were actually one query where we had this is TCPD that we did run, where we had one query that was slower.
Not join order benchmark.
And but
Before that?
Yeah.
Even we were on TCPH.
Yeah, TCPH. Yeah. So they have 10 queries, and in one of those the new optimizer was slower. So we did investigate that, and actually the cost calculations based on the information we had showed that we were doing the right thing. The old optimizer was probably using this 10% rule and happened to choose a better index by chance. But when we then added the new histograms, the new optimizer picked up also the new plan. So it can happen, but that this is one query in hundreds that I have seen.
So sheer luck on the side of the old one. So Vincenzo.
Okay, so we have some questions from the audience. Now we have the first one from Daniel Black. He's asking, how do background linear read-aheads affect cost calculations?
None. Actually, the read-ahead is based on that you get things more in the cache. So basically, if you had also read-ahead, you can increase or decrease the disk read ratio, because that's the calculation of how often do we have to go to disk. So anything related to disk, you have two variables.
All right. There's another question also from Daniel. He's asking me to talk about the file sort cost model and what we changed in it. And I can give a brief overview in that file sort also had a similar rule-based system where it would effectively always steer towards one approach or the other. But we actually went through the code, saw how many comparisons and where it reads and where it writes to temporary files. Added that in addition to how it would look if you were to, instead of doing file sort, if you had enough memory, if you were to be able to do merge sort, quick sort, sorry, in memory. And after adjusting the cost for these, like using just the normal math formula, number of rows times log of number of rows, where you add the initial read and the writes you have to do to the temporary files. We actually saw the optimizer produce better results than, better plans than before. The costs were actually correct and not what the rule would give you beforehand. So, yep, it actually went pretty well. Other than that, there's a question from Stefan Varocki. He's asking about analyze table, if it can be scheduled in the background as part of this big optimizer change.
I haven't touched the analyze. That's a separate part. And the thing with analyze, that most of the cost with selectivity, and so you have to run it once or twice on the database. If you have to have massive changes for it actually to be had to be scheduled again. I would just say that if you run it the first time you initialize the database, especially a slave, you run it once, then you should be fine. Because it actually can take some time. And we have some ideas of how to make some of the statistics much, much faster. And that actually on Vincenzo's table.
Yep. There is some work that we have to give credit for Microsoft. They have actually done quite some good documentation on how they collect statistics. And we're probably going to take some ideas from there.
Thank you, Vincenzo, and thank you, Monty.
Thank you.
So welcome back. This time we're not challenged with the difficulties of connecting to the virtual speaker. We have Daniel Black with us from the future. So he already has tomorrow 1:30 a.m. And we actually have two presentations around the theme of contributions. We will have the ending presentation by Andrew, a generic introduction into contribution with MariaDB Server. So this will be about some specific contributions. So go ahead, Daniel.
Okay, thanks, Kai. Well, I'm Daniel. I'm the Chief Innovation Officer at MariaDB Foundation. And we got to the topic of engaging the community because the products and the people that drive the products around MariaDB are what kind of makes the community actually worthwhile. Now, MariaDB has, a number of different roles in the community. It's as a consumer, it consumes open source tools like CMake, like compilers, like libraries. And as we go through the development, we've got to actually make sure that those work, and we work with a variety and report bugs in those every now and then to ensure that MariaDB that sort of gets to the end user is actually as good as possible. When MariaDB is consumed by users, it's also depending on like Linux kernels and other Unix kernels, the user space, the distros, or Windows. So we've got actually a role in ensuring that part of the community is integrated well with MariaDB. There's hardware, which is a whole different story, and thankfully, abstracted away by the operating system enough to expose details of usage in a consistent way. And I mean, MariaDB Server is developed, but then we're also actually dependent on others, like the distribution packages. The MariaDB Corporation actually puts a lot of work into open source connectors for MariaDB. But there's also community projects out there like PHP and the connectors in various different languages that are kind of working independently. But what we like to do at the foundation is to look over now and then and sort of see what they're doing and making sure they're sort of picking up on the new pictures that we're writing, the new syntaxes, things like ORMs, the object relational mappings in various languages have different constructs, and we want to actually make sure that if we've developed a feature and a syntax, that these ORMs can actually use the MariaDB features that are there, and ensuring that, even if you're using an ORM or a high-level language, that you're actually getting the benefit to MariaDB. In a way, the community is also very dependent on its users to, give MariaDB its purpose. And through commerce and the funding and sponsors and community projects, the users are actually also just creating the ecosystem and making it happen as well. Let's start with a story, and I'm going to give a story on containers. So prior to 2 years ago, the Docker official MariaDB was maintained what is now actually a Docker Incorporated owned company. And sort of at the time, I think it was fair to say that MariaDB was barely paying attention to containers, and then the foundation took over the day-to-day maintenance of it. And so the reason we did this is so we could have a stronger cohesion between the container and the server. You could see that in the container it was like working around server limitations, or the way the server did things, or the way the MariaDB installed DB script actually works. So there was an opportunity to actually start to bring some of the things in the container upstream. And now, in our continuous integration build log, we test every change of the server against what is going to become the next official Docker image. and this means we've actually grown a test suite in the normal way that containers are normally used. And we've seen that work well. We've seen over the last few years that the number of Jira bug reports that sort of just reporting general MariaDB issues, and they just happen to be running it in a container in their production. So we're proud to sort of see the little bugs in the container and that people are actually using it. Because we're running the build process in CI, what we're actually producing is a bleeding edge container that's available for everyone to use. So if you want to, test, whatever is the current state of what's going to be in the next release, it's always there. And by the time it gets to these Quay.io MariaDB Foundation / MariaDB develop container images, they're already complete by the server developers. They're in the mainline branch. The developers of the server consider them complete. And so if you want to actually see if something is the way you want for the next release, it's there. And because of CI, we've been able to simplify the elements of the container and also grow the functionality. And we're getting actually a reasonable range of contributions from the community on the container images. Picking up things like hashed passwords, putting them in. People have requested changes to the numbering and the labeling for release candidate releases, and so we've been able to accommodate a lot of those really quickly, and things like health checks. So that's the story. But there's also stories that sort of aren't actually about what happens from MariaDB. They're talking about what happens in the community. I'll begin with the story from about Trevor Gross. Back in May, sort of started on Zulip, sort of asking about Rust for the MariaDB server. Not something that's going to happen quickly, but not discouraged. He actually wrote a wrapper to UDF functions for Rust. So with the minimal effort, you can actually recreate your own UDF plugin to the server in a few lines of Rust, and you gain all the performance benefits of the language and also the type safety of the language. So this is there, and this is what the foundation can do by just being a friendly user who wants to try out and test new things that the community wishes to develop. Now, a blog on Rust, I spoke to Trevor earlier today, or yesterday, time zones, and he's going to get a blog out on the MariaDB blog about this soon, and he's sort of further looking into seeing what else you can do with Rust and to exposing some of the other plugins of MariaDB. In another instance, Martin Montes announced he'd written like a MariaDB Kubernetes operator on Reddit. And I think the best thing we can do as a foundation is to see these things and try them out and provide the encouragement and provide some feedback on things that work well, things that probably could be improved, and just appreciate that MariaDB Server isn't on its own, and that additional innovations from the community on their own are valuable contributions to the ecosystem. In the ecosystem, we've got Enclave.io and Edgeless actually both providing quite different secure Enclave SGX versions of MariaDB. And this is one way we see the open source nature of MariaDB and the skill sets in secure enclaves have made it available for users that want that functionality. Ultimately, MariaDB is actually, I guess, for the community, and so when we look around, we're looking at like Stack Overflow and Reddit and Zulip and knowledge-based questions and Twitter and everywhere else, geez, it gets to be a lot less after a while. And we try to just help users out. Some of them are beginners trying very new stuff, and we're thankful to have a number of people in the community, particularly on the Stack Overflow and DB Stack Exchange, that will help out people doing, how do I write this query kind of things. But every now and then there's questions that sort of are a little bit trickier or could actually use some of the newer functionality in MariaDB. And what we will do with those is to really take advantage of that and to show off the new features and show what can be done. Every now and one of these forums has got a person actually asking for help, but what they've actually really found is a bug, and we can encourage people to write the bug reports for those, and we can look at those bug reports and ensure that they get fixed. And some of them really shallow and others aren't. Unfortunately, we also see the bad side in these kind of communities. We see far too many people copying bad advice, like just delete your IB log files. It says in MariaDB error, that must be the fix, and sort of became a pseudo default solution, despite the numerous dangers of it. And we see Marco, thanks for writing like 10.8 that in 10.8 MariaDB won't actually start without it. So hopefully we can see some of this practice die away, or at least warnings come up. But we can actually sort of engage the community and put little notices up saying you're losing data, or read the error message a little bit better. And some of the cases we find out, well, okay, maybe the error message could have been written a little bit better. And myself have done a couple of fixes of those recently. Other things we come across in the community are people interacting with other products, whether it's a Go language ORM, doing some query, a DB deployer, Zen and Maxwell, that are doing something, but what these products actually aren't working with MariaDB as well as we can. And we can sort of take the hint from a help request that's really a bug report for someone else, and try to direct them into fixing a little bit of code so it's a lot smoother for the next person that tries to do a similar interaction. And of course there's the community contributions, and Andrew's going to talk about that later, so I'll add him to that. I sort of indicated in the abstract that I was actually going to talk about some of the challenges that we have before us as a MariaDB server and the community in general. And one aspect is like the technology is changing fast. There's frequent updates to Linux distros going on. There's that sort of is part of the usual kind of churn. But now there's like new things, like there's Windows ARM64, there's Windows got a Windows subsystem for Linux that does some emulation of Linux through Windows, that sort of provides an environment that people actually can actually run and start MariaDB up, but it's not something actually test currently. So there's a few ways in which it interacts that can be buggy and quite hard to trace down. And this is, I guess, one of the challenges of new technology, so that people just start using it and then we're going to catch up. The good thing about open source is that it constantly evolves. It's a part of the code base of 30-plus-year-old, as Monty just did in his optimizer talk. But just because it's old doesn't mean it can't be totally rewritten. Old assumptions thrown out and new ones placed in, and we can continually make it better. And all it just needs to do is shine the light on what is wrong, and we can to fixing it. As hinted in Monty's talk, that one of the challenges from MariaDB is we write these new features, we test them as best as I can, but is that good enough for everyone's scenario? We hope for the best, but if people can come along and test those out a little bit more, that would really help us a lot. And indicated, and Manuel's talk described it well, that testing things is a real burden. It really takes a lot of effort to test something properly enough to feel confident enough to deploy it. And we need to actually understand a bit more on how to make this more quicker and more automated. Delivering a nightly or per commit container queue is the easier bit. Integrating it in your environment, doing an A/B test or whatever to determine how it actually improves stuff. Is stuff getting better? Is the result changing? Is the query plan changing? And is that for the better? It's like the hard bit, and we've got to actually put a little bit more attention into working out with the users how that will be. So, yeah, and we're going through the process on that. Other things we have, we've got a limited number of people, doing documentation, and we're doing the best we can. We know that some things are falling behind, so we're trying to catch up. But if you see things are out of date or need explained better, do drop us a bug report, and we're here to help, and we will continue to do so. I think other things the foundation needs to do, we need to be a bit better about blogging about the new features. There's some that sort of slipped by that about like UCA collations that were added in 10.10 that are a huge step up from the UCA 5 standard that we were on previously. And I've seen some quite old timers that go, oh, MariaDB is still on that old 520 version, but nope, we've caught up, and we need to actually do better at like promoting that outwards. Out in the community, I think there's some projects that need more help actually integrating with MariaDB, and I think sadly we've missed the focus or the resources to actually focus on that. So it would be good to have more people to do so, but also user support. If you're using a product that doesn't actually integrate that well with MariaDB and you'd like it to, point it to us and we'll see what we can do. So that was my general talk, and I guess if we look at like some of the other community interactions that we've done over the year, we've come across things in like the Linux kernel with the way that Uring handles some situations. We've found sort of bugs there that we've needed to report, and we've really tried to actually be a good community player there. Recently started attending and looking at like the WordPress hosting meetups and seeing how the people are using WordPress there, and they're writing upgrade documentation. It's like, right, okay, we can look at like the database documentation around that, sort of see if it's correct. We can sort of come across wiki pages in Linux distros around MariaDB and check that all their pages are making sense and recommending the same things. And there is a lot of work that the community can do and will continue to do out of the world. So what I think I'll do is just wrap it up to you and sort of let you ask some questions about the community and the foundation of where you want to see it going.
Thank you, Daniel. So I would actually like to ask Monty the first question. You started with community things many, many years ago, before the times of Reddit or Stack Overflow or GitHub or Jira. So what would you think are the most innovative new ways of interacting with the community that you observed from Daniel's talk? Okay. So do you have any overall comments, Monty, at least?
Start with others.
Okay.
Okay, Dennis, I have one question for you first. So you've been helping out with community contributions this whole year. So what was the, let's say, most interesting contribution you had to review?
Oh, this year, geez. Just that come on, going rather quickly. I'll take that on notice and just do a quick look in the background on that.
Okay, so one that I liked was that we had a user from, he was trying to compile a MySQL on ARM on Windows and succeeded and submitted a patch for that, and he was very pleasantly surprised that with minimal modifications MariaDB also compiled on ARM on Windows. So
yeah, that was good. I think you said you just needed to fix a couple of test cases that that weren't actually working. So yeah, that's, I guess, one way we can do a lot there.
So building on that, I think it's. Okay. So building on that, I think it's very important that we work with the community, and this example shows one where we're very open to collaborate. Any other contributions you can think of?
There are, I guess, lots of fixes in like the OpenBSDs from like grad, fixing, improving the way various functions, and he's looks like he's getting ready to enable RocksDB again in the OpenBSD. There's, I think, some of the most interesting ones I've actually come across are in like some of the bug reports on, we've got a problem in a bug report, and we can either work around the problem or get that quick. There was one bug report that was just, I think, a day or two before about 2 releases ago, that sort of came in, and it was the deadlock display in MariaDB on the showing MariaDB status, like the numbering of which one was having the problems was actually wrong. And I thought, yeah, okay, that's really undoubtedly really trivial, but spent an hour and just found it and sort of fixed it and sort of give the user a really good experience on the things that I can actually fix really quickly.
Another thing to note is you mentioned we are trying to make sure we're good citizens with external projects. We introduced testing for various projects like PHPMyAdmin. We're running tests for WordPress. Can you recall a time, any moment during this year where we, let's say, didn't introduce a regression because of these sorts of tests?
I think there's been a few times where we've actually found problems in like DB deployer. There's about 2 or 3 times its tests in our CI system have failed, and we've raised that up to them, and they go, oh, cool, yep, we kind of knew that your numbering scheme, and you were basing port numbers on numbering scheme, and strangely enough, when you go to 1011 and start multiplying numbers together to get a port number, doesn't take long before you exceed the 64K of the port numbers that are allowed. So it's like really keen to see that, oh yeah, that's right, that's there, and that kind of feedback to him, before the releases came out. So DB Deploy was there. Ian was saying, he was using it for a while and came across the same issue and then did an update. It was like, oh, it's fixed. It's like, yeah, that's right. That's sort of what we try to do in that.
Okay, so a question from potentially the audience's perspective. So if I am a maintainer of an external project that relies on MariaDB, like for example DigiCam from KDE, what would be the best way to work with the foundation such that we have as few problems as possible whenever new versions come out? What would you recommend?
Well, I've seen a lot of the projects out there and are using like GitHub Actions for their workflow, for their CI. So normally they've put MariaDB as a container, they bring it up, they run in the test against that. So because we've got Quay.io images that are being generated, what we suggest is actually replace MariaDB colon 10.3 and put a MariaDB Quay.io/MariaDB Foundation/MariaDB Develop. I did a blog post a year ago on it. And put that in your CI. The container will work exactly the same way, and this is testing the code that is there before the release. It should be stable by the developers, and if you find any problems, you can actually get it fixed before the real end users end up with doing an upgrade and finding it not working.
Okay, and building up on this, any lessons you would like to share about interacting with Manuel from Wikimedia on the bug he just discussed?
Yeah, there's a lot of things about getting stack traces and trying to sort of dig with them. I think you and I both were looking at like their graphs on the performance when they were having the incident, and trying to actually where it was or where it started, and we tried to, I think, very blindly actually working with graphs on things and trying to make inferences of them, and maybe that's just
I remember we had a red herring there.
Lack of experience in that side of things. There's a bit of code that's like, just grab a stack trace and we'll just start to make that more. It wasn't quite enough as it turned out, but we're able to start to understand it a little bit more once we get that. And once Mark got that too, it was like, yep, okay, it's in this region. We now need to access the pool pages to decode this out. So the importance of clear details, especially from stack traces, even if it just gets an idea of the problem, is really good on bug reports. And
building on that, I know you had to explain to Manuel how to attach a GDB debugger to a running server.
Yeah.
Given that experience, do you think we could improve our tooling there, or let's say our tutorials, and make it easier for other projects to provide us the same level of feedback?
Yeah, so I mean, after that, I have actually done some edits on that knowledge base article, and there was genuine operational impact. Like, we're running on a server with where the core trace is quite large, and there was an aspect of taking a core dump and doing a backtrace live, that it was just losing state and couldn't be done. But then to actually instruct GDB to take a core dump and then go back and pull it out of the core dump because it wasn't working. And those kind of larger scale operational issues to the things that we don't actually see on laptops while we're testing.
Okay, so I guess the key takeaway here is we're happy to work with external parties. We all learn when we deal with a problem. So if you can reach out to us, assuming we are, it is in our power to help you. I think both MariaDB and the other projects stand to benefit if we work together on bugs, so to say.
Yeah, absolutely. There's certainly a lot to be gained, and there's certainly, as we're looking at the way other things are implemented, that we go, there's an easier way, or oh yeah, we should be doing that. Sometimes it just takes looking at some code that's sort of designed to work with MariaDB and MySQL and Postgres and that, to sort of see how much effort they actually put into differentiating minor differences in syntax. I know, Sergey and Monty will, follow the standard, wherever possible, but we're not adverse to following a useful or established syntax to try to minimize that. But every now and then there's little bits of syntax that show up that one server will tolerate and the other won't. It's good to try to clear that up for the good of the people trying to write versatile projects and database agnostic projects.
Yeah, just related to that, I want to make sure that it is said that contributing to open source is not only sending code, but also like sending bugs. I think people sometimes get scared of sending bugs. But I think it's also a way to contribute to a project. You don't have to be sending patches to be considered a contributor, but also like if you're able to send well defined bugs, that also helps a project. Whether they are fixed in a fast manner or not, it doesn't really matter that much, as long as you're giving the project the feedback. Okay, this is not working for me. Take a look when you can.
Understand it. Yeah, and you see some on the Stack Overflow. It's like, I've got this odd issue. It's like, no, it's not your issue. It's a server problem. And most of them, you've got a working test case that shows a problem. These are the ones that sort of can get fixed really quickly. So that these are the ones should be reported.
Okay, Daniel, so thank you very much for the presentation. So if there are any more questions, feel free to lay them out in the YouTube chat. So Daniel has been very active there and is happy to answer them then.
Yes.
Other than that, thank you very much, Daniel, and we'll see you around.
Thanks. Good
night.
Bye.
And do stay tuned, soon we'll have a live presentation in the next one. We'll have some setup time. So now we have a setup for the next presentation, and the next presentation is on MindsDB by Jorge Torres, familiar to you from several earlier server fests. And just to remind you, MindsDB is about machine learning and how to deeply integrate machine learning into MariaDB. I would say it's both for reading data into machine language and then reporting data out of machine learning type of concepts. And now this is not just a general intro to it, but a live demo, so very much looking forward to having you here on stage. Jorge.
Thank you.
You have a mic.
Yeah, I have it. Can you guys hear me? Okay, well, thank you very much. The idea of MindsDB is simple, and as Kai was describing it, we want to make sure that we can bring the capabilities of machine learning to the data layer, because we believe it belongs there. And let me walk you through that concept a little bit more. The approach that most people take to machine learning is a model-centric approach to machine learning. And that works if you're doing research. If you probably work at building self-driving cars and the like. But if you want to really get to applied machine learning, a model-centric approach carries a lot of things that down the line make it very difficult. The first one is that people that start with a model-centric approach, they don't really care too much about where the data is coming from. So many of them start with they extract some data from the database, put it in some files, and start massaging this data on pandas or whatever is the tool that they choose to do this on their computer. And they do iterations of this. So essentially, they iterate the data frame, and then they train a model. And then they see how the model performs, and they try to improve that by iterating on the data frame again. And eventually, they have a model that they think that they like. But the problem is that once you have it like this, you soon realize that the data is actually coming from a database. So now you have to maintain a system to run all of the spaghetti code that you did on pandas. And every time that you want to do a prediction, you need to extract data from the database, run it through this transformation, whatever transformations that you were making, and then be able to pipe this into the model. Now, the way that most people deploy models is behind a RESTful API service, something like MLflow, RaySurf, or they sometimes do it with their own scissors. But at the end, every time that you need to do a prediction, now you need to orchestrate whatever ETLing that you built, and then you need to pipe that into the actual web service. And then you get the predictions, but usually these predictions cannot be consumed directly as well. So you need to go and put the data back into the data warehouse or the database. And this is also not ideal. Say, for instance, if you have a tool like a BA tool like Tableau, etc., you have to now run all the process of ETLing, running the model, putting the predictions back into MariaDB, and then actually be able to use those predictions back forth. So this dance of ETLing and data and where the data is at and running the model and orchestrating all of these different blocks can be reduced if you take an approach that is of bringing machine learning down to the data layer. So essentially, if this database already contains the information that you need for training your model, then actually you can leverage all the capabilities that MariaDB brings into the table to do data transformations. At the end, MariaDB has been around for a long time, and it carries the knowledge of a lot of database building for you to transform data. So if your data is there, then leverage that capability to train the model using like the transformations that the database provides for you directly from the data that is coming from the database. And then when you want to consume the model, we decided to make an abstraction that makes machine learning models pretty much first-class citizens in the data layer. In the data layer, the first-class citizen is a table. And what the abstraction that we brought into the mix was, okay, why don't we present machine learning models as tables as well, so that you can combine information with models, you can up the stack. So anything that connects to a database can still interact the same way that they interact with tables. And this abstraction makes it also so that you don't have to think of deployment. As soon as you create a model with MindsDB, or you bring your own model to MindsDB, then this model can be consumed in a way that it's almost instantaneous. I'll walk you through a demo in a few seconds. But one of the key interesting elements of MindsDB, and the reason that MindsDB has evolved so dramatically, is because this concept is very simple for anyone that is a developer that is used to working in a database, which, you know, there are many of us. Now, the second part is we started with the idea of bringing machine learning, and in that first part, we had an intuition of how to do machine learning for many of the problems of databases. We have our own AutoML capability that ships in with MariaDB and MindsDB, but we started to realize that there are many different ML frameworks out there. And in reality, it doesn't make sense for us to, for instance, build a Hugging Face when there is a full ecosystem of people building machine learning models for text and for NLP tasks, or building another OpenAI, or building, you know, like a scikit-learn, etc. And the approach that MindsDB decided to take was, why don't we just bring the whole ecosystem to the data layer? And for a better word of how to actually glue all of those ideas together, let's just walk you through a demo. All right, so MindsDB works and behaves like a MariaDB database or like a MySQL database. You can connect to it from any MySQL client or MariaDB client. Yet, for simplicity, we also, you know, when you deploy MindsDB in your server, you can connect to it like to the web interface that we provide, and you have like your own IDE that you can kind of run queries into it. But at the end, you can use the same client that you use to connect to MariaDB to connect to MindsDB. Speaks the same protocol and same wire protocol. But the concept is simple. And for the sake of this example, we're going to bring in a sophisticated model for sentiment analysis that is on Hugging Face. Now, for those of you that are not familiar with Hugging Face is this ecosystem of people building transformers for NLP tasks. And you have, right now, approximately like thousands of different models depending on your different tasks. So you don't have to actually go and build these NLP tasks. Now, the purpose of this demo is to showcase how in databases like in MariaDB, you may have columns that have text. And these columns, when they contain rich text, actually they're obscured. You know, like it's unstructured data within structured data. And if you want to do analytics, or if you want to like actually make use of this information for like some other like tasks down the line, you actually have to apply machine learning. So there is no way that you can plug, say, for instance, Tableau into your MariaDB database, and if you have some columns there, that you can actually extract information for analytics just with that data that is. The only way that you can do it is by running an NLP task that will extract the information that is structured information so you can actually use it. In this case, we're going to run through an example where you have text and you want to extract the sentiment. Say, for instance, you have a retail store and you have thousands of products and you have all of the reviews that people are doing on the different products, and you want to know in aggregate, how are your products doing, or how are they doing by product, etc. So the way that we bring this capability is, okay, let's bring a model that is in the Hugging Face ecosystem as a table, and then once you bring that model as a table, you can query it as if it was a table, but you can also join it with another table. So you can say, okay, join this model with all the customer reviews that I have, and then you will have actual, you know, sentiment keywords that you can use for analytics. Now, for the sake of this example, we have a test MariaDB dataset, and let me just walk you a little bit through what is in this table. It's a simple table that has, you know, random text, and what we want to do is actually be able to analyze sentiment on some of those. Now, for the sake of simplicity, we're going to do a model that brings sentiment, a new column called sentiment. We're going to use the Hugging Face engine. It's a text classification problem, and this is the actual router to the Hugging Face ecosystem. If you guys are familiar with Hugging Face or not, at the end we have like a full documentation as to how you can pick of all of the Hugging Face models that exist out there, which one is like the most suitable for you. Now, the column that we want to do sentiment analysis on is in this short text. Now, I don't hate Australia. This is just like something that happened on the data set that we put in. But the whole point here is, can we run sentiment on this type of sentences? And can we just actually join this model that we're going to bring as a table with this particular table? Now, The labels that we want to extract from this particular column is it negative, is it neutral, or is it positive? Now, for the better use of our time, I had already pre-trained this model, but I'm going to leave this one running so we can show you in a little bit how that works. Now, what this does in MindsDB is that it brings from the Hugging Face ecosystem the model into the MindsDB server, and then it instantiates it as a table. It will take a little while for the model to kind of like fine-tune depending on these conditions that we have, but I already have a model that I pre-trained here. And if we run this statement, it's going to tell me, okay, the sentiment classifier is complete because I already had done this before. We can see the one that is actually training right now. And it's generating it. But since I had already trained one before, we can get into like the fun part of this. If you treat a model like a table, then whatever you have in the work conditions are the input for the model. And you will get the output of the model, again, formatted as if it was a table itself. So let's do that here. I'm selecting from the model sentiment classifier, which is the one that I had trained. And I want to, where the condition here is like, assuming there's a column called text short, and I will put this, this text here that we want to get some sentiment from, and we will select that information here. So let's just run this. Now, it's saying that it's positive. Let's just change this to something very negative. Very bad. You can see it's negative. Or, I don't know if someone from here in the audience.
This is an evening.
Huh? Sorry?
This is an evening.
Yeah, let's see.
Neutral, yeah, work.
Yep. So now what we're going to do is actually do a join of this model with this table. And let's just look at the table again, but only at the column that we're going to predict. Again, please believe me that this is text that we put somewhere in the database. Negative or positive is not the way that we feel about Australia or any of this. It's just the example that we had, so that we can have like one negative, one positive, one whatever. Yeah. And given that this is one table, we're going to join this table with the model, and we should get a prediction for each one of those. And there you have it. So this is, in my opinion, super interesting, because what you're doing here is you're bringing all of the work that a lot of people have already done and making sure that they're really powerful ML models for NLP with one single statement as a table. And then now that you have it as a table, you can do crazy things like this one. You can join with other tables that you have. And then you're applying machine learning in a way that is natural to someone that knows how to do SQL. And if that table exists in MariaDB, then you can actually leverage all the capabilities that you already have for MariaDB data transformations. Now, the cool thing about MindsDB supporting the MySQL wire protocol is that you can import this table, or even MindsDB has a construct of views, or even the table that we generated as a model as an external table to MariaDB. So we can actually leverage on the capabilities of external tables to bring this even to the point that you don't have to go outside of MariaDB to do this type of predictions. Anyway, I wanted to make it quick, and hopefully with this information you guys have all you need to actually start applying machine learning to your existing data. Of course, NLP is not the only thing that is out there. MindsDB supports hundreds of, now we're close to like hundreds of different types of models that you may have: time series, imputation, NLP, even for image classification if you have blobs. So I invite everyone to try it. It's becoming now as simple as this, it's just like a few statements for you to be able to apply state-of-the-art machine learning at the data layer. And I think that for the MariaDB community, this is actually super useful. So, questions?
So Jorge, one question. I didn't see how the model got its initial data. Can you show the first query a little bit and explain how you give it the training data?
Yeah, so in this particular case, we're bringing a model that is a Hugging Face model. So you're in this statement, you're only telling it, okay, I actually just want to make sure that I create a new column called sentiment every time I call this model, and that I use the input column called text short, assuming that you know what you're going to join with has to have a column called text short. Now, for the Hugging Face examples, you can fine tune them, so you can say, okay, from, you could say train from, and then you can have your select statement here, and then whatever table you have, that you have your data. But the cool thing about Hugging Face is that Hugging Face is an ecosystem of already hundreds or probably close to thousands of models that are already pre-trained. So you don't have to do this. If you want to fine-tune them, fine. But sentiment analysis is such a kind of like well-known task that this will work off the shelf. When it comes to the syntax that we have for different problems, at the end, MindsDB supports is like train from, and then you pass the select statement that you want to train for a specific task. But for NLP, you don't even have to train the models with your data. You just use them.
So I have a question which actually might be outside of the scope, and then tell me it is. It might be AI in general and not machine learning. So given that we have Wikimedia Foundation here today, we've spoken about Wikidata, and I'm looking at like a popular culture kind of thing with the wall-E thing that creates art based on a character string. And what it needs to do then, and it's not a learning model as such, it is parsing and understanding a sentence. So there was this piece of art where Putin is having a tea party with Moomin, with the characters from Finland. And to understand that concept, I mean, it then painted a picture or a fake photo of Putin having a tea party with Moomin. To make that happen, I would assume that the place to have the understanding is Wikidata, where the concept of Moomin and Putin and Tea Party exist. So the very fluffy question here is, understanding and parsing language, is that in any way part of this machine learning process, or is it an entirely different type of AI?
Yeah, so of the ones that do this type of task that I know the most of is DALL-E from OpenAI.
Yeah, I said Wall-E, I meant DALL-E, yes.
And of course it's trained on most of the data that they can kind of crawl from the internet, including the Wikipedia data sets. But they try to source data from many other places. Now, the challenge now with OpenAI is that the data sets are not public. So we don't really know the extent of what is being trained there or not. But going back to the applications of that as to what we do, there is an integration that is happening right now for MindsDB to OpenAI, so that people can say, okay, well, I want to join a model that has text, and then the output will be a blob that you can put in another column, and therefore you can generate images for a whole bunch of input text that you have. Yeah. What I'm trying to convey here is, even those use cases that are more in the realm of AI, they still, for you to be able to productionize some sort of application, sometimes it's easier if that lives in the data layer, especially when you want to do bulk operations of that kind. Say, for instance, you have a store that generates postcards based on what people write, and people write a message, and then it will just eventually start mailing those postcards, and it uses DALL-E to do this. As a developer, one way to do this is you make calls to the DALL-E API, RESTful API every time it happens. Where another one is, you let these things get into a database, and then you do like bulk operations, so you actually make thousands of calls at once as opposed to one at a time. So it really gives options to the developer to leverage the capabilities of doing this in the data layer. Now, there are use cases that still are not necessarily best suited for machine learning in the data layer. Say, for instance, a self-driving car. Like at the end, for a self-driving car, a lot of the problems that involve with computer vision, you don't have to go to the data layer to actually apply machine learning. You need to do it on the fly, and therefore that's not a problem that we fit within a realm. But for developers and app developers and people who are building systems, then this is a suitable use case. And so long they find it suitable, if the integration is not there for MindsDB, now we've made it very simple for people to write integrations to probably any ML framework that is out there. The biggest simplification that we made to MindsDB this year was the ability to attach the machine learning capability that we provide with, which is called Lightwood, and replace that with any framework. So to that extent, if you believe that your use case is this one of DALL-E, then you can actually do it. Now, let's go back to another point that you bring up is, do you want to fine-tune these models with, say, data that you have in Wikipedia? For sure, then it will be much easier to do it if that data is already in some sort of database than if you have to kind of crawl and now loop through like each of the different pieces of text to actually train. So let me go back to this slide here, which is the ability to do machine learning like this is twofold. It's one that you can train from the data that exists in the database, and that you can consume this as if it was data that exists in the database as well. For many of these problems like the one in DALL-E, maybe if you want to fine-tune a model like this one, it may be easier if you start crawling the data, putting it in the database so you can have it organized, and then train the model. Yes, absolutely. Sorry, the question was...
Yeah, I think that was sort of answering even more than I had asked for. So you were saying that, well, I'm sort of interpreting your answer as saying that MindsDB is a user interface, if you will, to deliver the results by existing other models, which in theory could be delivering a blob like DALL-E does. But my question was more of a subset of that one, the understanding of what is the input text. And you said you're talking, or people are always talking about training models with ML. I'm thinking about the accumulated knowledge that exists in open data, as usually thought of as Wikipedia, but more on a fundamentally abstract level, Wikidata, where the concepts are already parsed into a structure. And that structure, does it have any, would you put that into a specific model which sort of is already learned or already taught, because that structure has been crafted by the world, the community of open data that has created Wikidata?
Yeah. So I don't know what initiatives right now use the metadata that exists over big corpuses of text like the one in Wikipedia and Wikidata. I know that the way that transformers learn is more like how we believe that we learn, which is sequence models. So essentially, you start feeding a lot of sequential information, and eventually these neural networks start to build patterns as to, you know, what are the associations that happen between like the subsequent events. Now, text can be seen as a sequence of events, because you have one word and then the next word and then the next word and the next word. And even so, you can go even lower than that. You have one letter and then the next letter, the next letter, the next letter. And eventually, if you make this type of sequential learning, then the structure of that information is represented by the neural network itself. And therefore, you don't have to label it. And this is what is known as, so you have two ways of doing machine learning. You have machine learning that you have to label data, yeah? And then unsupervised learning where you don't have to label data. In this one, since the data in itself has, like, especially when you're dealing with text, when we're dealing with images, has a lot of context in itself, then these are called self-supervised learning algorithms. And that's where DALL-E, and that's where, like the GPT-3 and etc. Like even most of the models that you find in Hugging Face are of that kind, transformers. And therefore, it is not necessary for you to feed in the metadata of how that information is structured, because that structure eventually gets learned by just observing the patterns and the sequences that exist within that information. Hopefully that
I think that was a clear answer. It's sort of, in a way, the answer was no, you do not sort of directly transform the neural network of Wikidata into a model, but instead you observe and learn from the sequence of words or sequence of characters or sequences.
Could you go back to your example? And speaking of labels, you in the code you actually label positive, neutral. How does that relate to the model? I'm curious is how that, where you get negative, neutral, and positive.
Yeah, so Hugging Face is an ecosystem of pre-trained models for NLP initially. Now they have it for more than NLP. And the model that we're using here is this one. Yeah. So this one is a model that they trained on the Twitter data. So actually they pulled a whole bunch of information on Twitter, and then a whole bunch of people started labeling if they had like different sentiment, like positive, negative, etc., etc. Yeah. And therefore this model is already trained on millions, probably billions of records of Twitter on how to label things that are positive, negative, and neutral. But also you can add other types of labels, and it will try to like infer those labels from the structure that it has already. And therefore, when you're telling it, okay, what labels do I want to extract, then these are the ones that you can. Now, the way that many of these models work is that they map the language into, say for instance, a hyperplane, yeah? And then similar concepts are grouped in different clusters, yeah? And eventually, if you want to specify a label, then what you have to do is find where that label belongs in one of those clusters. And then anything that, when you map a sentence into that hyperplane, then if it lands very close to that point, then it labels it at that. So in theory, you can specify any label that you want for this particular model, and so long the model has observed that word before, then it can actually classify this information, because as you do the transformation that lands that into that hyperplane, it is a distance function as to which one is the closest. Again, I don't know the internal mechanics of this particular model, but that's how many of these Roberta models work. Now, the interesting thing here is, for most developers, really what you want to get is the task done. You want to make sure that I'm a developer as well. I know machine learning, but I ultimately am a developer, and I just want to be able to apply these concepts without having to know the mathematics behind it or to get a PhD in this stuff. It doesn't make sense for me to do it, but it makes sense for me to apply it. And therefore, I think that when we built MindsDB, we built it with that type of individual in mind. Someone that, if you want, you can go and learn the details of how this thing is actually working, but you don't have to, so long it works. And that's what we bring into the table. Now, the beauty of this as well is that research and machine learning changes really fast. And by making these abstractions, you can make sure that you can always be using the state of the art, so long someone already integrated a piece of state of the art. And you can build cool stuff. Like at the end, we developers, we're people that build things. And this is just a hammer and a nail that someone hands to us, and then we can keep on, building the way that we do. But yeah, I think that I'm answering questions in a longer way than what the question is, but I just wanted to provide more context as to how and why we do MindsDB the way that we do it.
Maybe just a request of a clarification of answer to Kai's question. So when you are learning from the select statement that you already have, do the models just want to go through this result set once sequentially, or there are models which want to like traverse it multiple ways, or wanted the input data to be sorted, or anything like that?
Yeah, so if I understand your question correctly, let's assume that you actually use the train from, and what it does now is that it downloads this model and then fine-tunes this model with a specific corpus of data, yeah? Which is something that you actually want to do if you think that your data is particularly different from, say, Twitter, which maybe it is, you know? And therefore, you want to leverage on the existence of a model that already has seen a lot of things in a very generic way, and then you can fine-tune this model to perform really well with your particular data. Right. And therefore, that's when you want to do it. That's if you actually want to tell it train from this particular set, it's not that it's going to start from scratch, it's actually going to fine-tune the model so that, you know, the model learns from that new corpus, but still carries on the generalizations that it can carry on from having learned from a larger corpus. Because in reality, most people don't have data sets as Wikipedia or as, you know, like the entire Twitter data set. Like most people, databases aren't that big. So you can leverage on the existence of someone that went through the effort of training on that very large corpus, and then you can specialize that model to your own specific type of data. Yeah.
But do you do that by just, will it go just once through your, will it go just once through your data set when training, or will it require multiple passes, like reading the data many times, or reading it sorted, or somehow?
So in machine learning, the language for like how many times you go through a specific data set, it's called epochs. And then you can specify the number of epochs that you want this to do. But if you don't specify it, then the way that these models get trained is they will start training until there is like some measurement of overfitting. So essentially, once the model thinks that it's not learning, it's actually de-learning from just repeating too much, then it will stop. Yeah.
So you said that you can change the labels. Do you have to retrain every time you change any label, if you add one or remove one?
You don't have to retrain this particular model, but there are models where you have to retrain. But this particular, you don't. Like you can specify as many labels as you want, and again, those labels get mapped into, you know, some hyperplane, and therefore, so long this model has observed that information before, then you can still get those labels out. Let's assume that this is only English Twitter feeds, and therefore, if you wanted to get a label for, I don't know, Mandarin, positive, negative, then this model will not have ever observed this information because, you know, you only trained it with the English corpus of Twitter, and therefore it wouldn't be able to perform this type of task. And in that case, it makes sense for you to say, okay, well, train from, and whatever you have, like your specific language.
I'm surprised it found any positive comments on Twitter.
Yeah, it's a hot topic, of which I defer to give opinions.
So, for a change, a fairly easy question. How do we, if I'm excited about this, how do I test it?
Yeah, you can go to cloud.mysdb.com. We have the connector for MariaDB there. So you just create an account and connect your MariaDB and start playing with it. Everything that you need to actually do this is in docs.mysdb.com. We have like a learning hub here as well that can walk you through like the different tasks, including the NLP, etc. So yeah, I think that just go to cloud.mysdb.com and try it. Or you can deploy MySQL in your cluster just using Docker, which is kind of like the way that we recommend most people to do it now.
More questions?
Okay, so one question I have is this language that you're describing in the example there, is that like a combination of SQL plus some extensions?
Yeah.
Can you go into detail on how much you've extended?
Yeah, so we made a few extensions that we believe hopefully the database makers feel is comfortable in a way. So we didn't try to derail too much from like the concepts of, okay, create, drop, etc. It's just that now we add a new type of object to it. So in this case, model, but the syntax is similar to that of creating a table, with like of course some like sugar on the side. But we wanted to make sure that it felt very natural for someone that already knows SQL. Yet you can call it SQL Plus because we needed to add machine learning capabilities to it. But they should feel as natural to someone as they would when they were creating a table view, etc. Now, for querying the predictor, you're actually querying that the same way that you query a table. You're just selecting from a model as if it was a table, and then whatever you have in the word statement is the same. So we didn't change any of that. We did change the join, so you don't have to specify on what you're joining, because the model already kind of is trained to observe information from a specific set of columns. So we removed like the on for the join. It's just like you can join a table with a model and like this. Now, of course, the best way to, say for instance, export this capability to MariaDB is if you create a view with this join, which we support the same syntax that MariaDB does for creating view. So you create a view as, and then you have like the actual statement. And then that view, since MindsDB supports the MySQL wire protocol, you can bring that view as an external table to MariaDB if your instance of MariaDB supports like some sort of external table capabilities. Yeah.
Jorge Torres, thank you very much for a truly interesting presentation on MindsDB. Thank you.
Thank you so much.
So now it's time for our next session, Respect the Stack. And this one I'm not only going to introduce, I will also be part of it. And there's actually two people joining me later on virtually, not present here in the audience. So Respect the Stack is about one of the core values of MariaDB Foundation, namely continuity. So we talk about three values that we have. We have openness, we have adoption, and we have continuity. And openness is about the ability to take contributions on a code level or a documentation level or bug reports or whatnot, getting contributions from the community. Adoption is our goal to be able to spread MariaDB Server to a very large user base, regardless of whether that user base is a customer of an entity or not. And in order to fulfill those two goals of adoption and openness, we have the third one, which is continuity, meaning regardless of the set of financial entities interested in MariaDB, we shall be able to fulfill those two goals over the years to come. And that, of course, involves working with sponsors who have aligned interests with ours. And that's the setup in which the two guests here are invited. Well, one of them is actually not so much a guest. It's Søren von Farchmin, our Chief Revenue Officer, with a lot of background in various types of open source. And I will ask him to join me on stage first. I'll just mention that we, of course, have had a number of sponsors over the years. And we're now looking at extending that type of, extending our sponsorship program to new types of sponsors. And as part of that, we've asked Søren not just to join me here on stage, but to join MariaDB Foundation as such, as Chief Revenue Officer. So let's now see if technology is on our side and we can invite Søren also on stage.
Yes, hello Kai, and it's great to be here. Do you see me? Do you hear me?
I see you and I hear you, so that's great. So can you share a bit about your pre-MariaDB background, like CloudFest and all of that?
Yes, definitely, Kai. So basically, let me maybe reflect on 3 previous stations, what I did there, and my relation to OSS, and specifically the database landscape and MariaDB. So in the early 2000s, we started with a couple of other students a web server control panel software in Germany. It was called Confix. You might know this product right now under the name Plesk or cPanel. It's like the de facto standard basically in this web server environments for shared hosting, VPS hosting, dedicated hosting. This company ended up in Parallels. There were several products added to it, and I was basically the first employee back then in Europe and in Asia. So I'm kind of considered a co-founder of Parallels, which became a big unicorn company. You may know one of the products in the consumer space is Parallels Desktop for Mac, which was the first virtualization software to run Windows on a Mac. And back then in 2007, basically I was asked if I can build the business development department for Parallels with a basic and main step or goal to build an ecosystem in Parallels. And that was the first time I got in touch with Monty and back then Morten Mikos, the former CEO of MySQL AB. And back in 2007, we basically did the deal where MySQL was helping us with what we needed to achieve. After that, I worked for a venture capital fund called Runa Capital. Runa Capital in Fund 3 is, as some of you might know, also one of the investors in MariaDB Inc. in the commercial entity. They were also an investor in Nginx, which got sold to F5. So, and I was basically there in the very beginning in the early 2010s. And yeah, this was when we invested into Nginx, and we invested into 2-3 companies which had an angle actually to MariaDB. And in 2012, when Monty just started with MariaDB, I went with one of our startups which we invested we flew into Finland, to Helsinki, and that's the first time I met Anna and Monty in person. This is already 10 years ago. And now the third part, and that is maybe, I would say for me personally, the most fulfilling and exciting, since like 2013 or 2014, I'm running this conference called LiveFest. It's the largest industry event for the so-called cloud service provider industry. So it's like 8,500 attendees from over 80 countries. And the audience are these, like, say, the typical product managers who build products in companies such as GoDaddy or GMO in Japan or iChina in China, or Google Cloud product managers are coming, AWS, all the hyperscalers, OVH, DigitalOcean. So the representatives, attendees from those companies are basically the attendees we have at the conference. And on the supplier side, it's like everyone who's supplying to hyperscalers, hosting / cloud computing companies, from Intel over Microsoft to 200 more. And my job, and that is, I would say, one of my favorite jobs ever had, is like, I'm in charge of the agenda and the speakers. And a couple of years ago, I started this thing called the Inventor Of. So, I mean, at the conference, we had like amazing people speak, like at Snowden in 2015, we were the first ones to have him speak, or Julian Assange, Buzz Aldrin, Voss. But what I learned is, like, when we had people speak like Igor from Nginx, or Brian Bielendorf from Apache, or Mark Shuttleworth from Ubuntu, or James Gosling from Java, and Monty from MariaDB, like, they are the real rock stars. They are these industry heroes, you know, our attendees like to see. And yeah, that was maybe already a little bit long, but that is basically my jobs and the relation to MariaDB.
Cool. Yes. Well, you actually answered a couple of the follow-up questions I also had. But let me now next ask you specifically about databases. How much did databases turn up in that previous life of yours? And then we'll, after that, look at what you've been doing inside, or what we have been doing together inside MariaDB. Well, how did databases come up prior to you joining us?
Yes, very good point. I mean, if you look at this specific industry of these cloud service providers, web hosters, WordPress hosters, however you want to call them, there's a couple of parameters why MariaDB is extremely exciting, especially from the standpoint of awareness, I would say. Why? Kai and me, we had the opportunity to talk to a couple of the large hosters who are using MariaDB, and this comes from different angles. So, I mean, this session is called Respect the Step. You know, if you look at the LAMP stack, the M stands for MariaDB, obviously. So our first question when we talk to the hosters like 1&1, Jonas, or GoDaddy is like, how does your database landscape is looking like? And particularly in regard of MariaDB. And if you talk to these guys, you know, the answer is, oh, we are running 3 million databases on MariaDB. We are running 8 million databases on MariaDB. So it's huge, you know, and all these guys, they build on the de facto stack. And there's a couple of things why this industry is so interesting. So if you look at the OS distries, which are most widely used in these web hosting landscapes, it's one of them is Debian. And Debian comes by default, you know, with the distro. MariaDB comes by default with Debian, and you look at the control panels which are widely used, like cPanel and Flask. They also favor MariaDB. And if you look at the whole WordPress landscape itself, you know, I mean, we know that 40% of all the websites are running on WordPress nowadays. That's almost every second website in the world, and by far MariaDB is in favor from all these providers who are offering WordPress hosting nowadays. So we see like a 10 times faster growth compared to MySQL at those hosters, which Kai we already talked to.
Cool. Yes. So they are of various different sizes, these companies that you have been talking to, and I've had the privilege to talk to a number of them as well. And I think it's up to you now, Søren, to introduce the following guest here in this session, because I want you to give the background a bit about what kind of a company and why we've decided to invite that particular person. So please, Søren, go ahead.
Yes, sure. So we are actually creating this new category called Cloud Service Provider Partner. It's distinguishing from the bigger guys like Microsoft, IBM, or Alibaba. But we think, that these cloud service providers deserve an own category. And from all the conversations we have, we get positive feedback, when we ask, why don't you donate to MariaDB Foundation? It's they say, no one asked us before. So there's definitely, a need, to talk to them. So that's why we created this Respect the Stack program. And I would like to introduce right now a very, very good friend, long-term business partners, who's kind of our showcase, our first partner in this category, who's representing perfectly what we try to do. Please welcome Dom Taylor with us.
Hi everyone, how you doing? Hi Søren, nice to see you.
Hi Dom, really good to have you here. So I met with you before. I know you as a serial entrepreneur, and you don't look like you would come from the place that your company comes from right now. So you've been running one of the largest hosting companies in the UK, which then ended up somehow in GoDaddy, and now you are co-founder and CTO in the United Arab Emirates, the fastest growing web host there, Tasjeel. So can you give some more background, both about yourself and about Tasjeel.ae?
Yeah, sure. So I started web hosting back in 2004, I think, maybe 2003. So I was one of the early users of cPanel and Plesk, and obviously also Apache, and back in those days it was MySQL. And I built that company basically from my bedroom, which from my house. Everything I seem to do is from my house. This is not in Dubai at the moment. This is in the southwest in the UK. It's there's no 400-year-old fireplaces in Dubai, I don't think. So I built that Paragon Internet Group in the UK, and we ended up with 250,000 customers. Built our own data center in London, or just outside London. And we ended up selling to Host Europe Group, which then became GoDaddy in about 2015. And then I wanted to look for the next stage of growth, next opportunities, and that's how I ended up in Dubai, buying one of the oldest domain name registrars over there. So we're the second oldest accredited .ae registrar, and we thought, these people need to be introduced to modern web hosting, because a lot of them were buying hosting from American companies, from foreign companies. There wasn't really a local market. The web designer industry was only sort of getting going. There wasn't any good local WordPress hosting. So basically I took everything that I'd done in the UK and replicated it out to Dubai. My colleague, Wahid, is in Dubai at the moment. He couldn't join us, unfortunately. And now I think we have over 10,000 customers in Dubai, and we run a few 100,000 MariaDB databases. And yeah, it's really interesting actually. A lot of our customers do ask specifically for MariaDB. So then obviously Søren approached me as a cloud provider to see what I thought about the MariaDB Foundation.
Sure. So I'd like to hand over a couple of the questions for Søren, but let me first ask you about your first encounter with MariaDB. How did you first get in touch with MariaDB? What kind of a scenario was that?
Our customers have always wanted performance. So I've been running websites and WordPress sites and e-commerce sites, Magento as well. All these web applications, which basically are they're good pieces of software, but because they're open source, all sorts of people can write all sorts of add-ons, and they might not necessarily be optimized. So everyone wants the best possible performance. So really, it was me sort of sitting there with a MySQL handbook, trying to work out how the thing works to make it as efficient as possible. For our customers, they didn't have database admins. So I think probably 10 years ago, I tried that for Kona, and then obviously MySQL got acquired by Oracle, and at that point, everyone sort of started looking around. I don't really know how I came across MariaDB. I think it was performance benchmarks, because ultimately what my customers care about is performance. And then, the whole open source ethos is a very close second. But I think it was the fact that the performance and the development. And even looking this year, even the last 1-2 years, the pace of development at MariaDB is just incredible. I can't keep up with all the releases. And if you look at the MySQL world, there's not nearly as much going on there. So yeah, it's just performance and the open nature of it.
Cool. Well, Søren, would you wish to take a couple of questions from your side?
Yes, sure. So Dom, at what point in time did you saw the change in this small little industry, which we are both in for a long time, from MySQL to MariaDB? What was the changing point? Basically, when MariaDB became more important for building products?
I would say definitely, it was sort of definitely the end of my time at Paragon. So around 2015 is when we weren't running much MySQL. We were running mostly Percona, and then definitely in the last 4 to 5 years really is when we've just started deploying MariaDB all the time. I think we have maybe a dozen customers who run MySQL for whatever reason. But certainly, yeah, the last 5 years, especially I'd say the last 18 months, no one has ever asked for MySQL. I think 95% of what we do is MariaDB. It just seems the pace of development is great. The performance improvements, the NADB improvements, all sorts of more technical things, which I've been listening to today, and I'm definitely far outclassed. So I won't.
I mean, like Kai said before, it's like a very niche market, but we never really asked or talked to all these providers before, these hosting providers. And we definitely see a chance in that industry, to gain more partners for our nonprofit foundation, which all goes into development, obviously. So asking you directly, what would you say what we as a foundation can do better to serve that specific market? Of you guys who are running 100,000 of databases, and you're not even the big guys, you're a small good hosting company in UAE, with 100,000 of databases. So what can we do better as a foundation to serve that need?
Well, I know that MariaDB works quite closely with WebPros now, with cPanel, and with the control panels. So, yeah, like you say, it's probably not something that's come up very much, but the more integration with control panels, the better. I guess integration with cPanel is probably fairly basic at the moment, because it's just creating databases, users, and privileges. Lots of the performance settings and the different various settings for the thousands of settings. I think cPanel is just getting going with that. So the more we can expose to the end users to make their lives easier and to make their websites faster and reduce our support load, it all helps. So documentation, interfaces, recommended settings. Obviously, people run these SQL tuning scripts and come up with hundreds of ideas, and most of them are rubbish. So yeah, just end user integration really. Making sure there's always compatibility there with MySQL, because we migrate a lot of people in from other hosting companies who might, they might be running MySQL 5.7 or, an older version, because they might be a terrible legacy hosting company. So the backward compatibility is obviously crucially important.
Okay, Kai, do you have any more questions?
Yeah. So I was thinking, already in our earlier discussions with you, Dom, I was amazed at the level of technical depth you go to inside databases, and being a hosting provider, I suppose you go to that technical depth also in other areas. So how important is open source as a concept, open source software for you, and why do you support it?
So I think it's a very important, I'd say movement, it's a very important ethos, because a lot of our customers are sort of small-time web developers. They're not big corporates. You know, they have the same sort of mindset, if that makes sense, as MariaDB. Obviously, we know why MariaDB exists. A lot of our customers share the same sentiments, really, and it makes it more accessible for everyone. Because I think I said to you the other day that we had a customer move in from a MySQL server to MariaDB, and for whatever reason, their query was 10 times slower. And I was watching earlier about the optimizer tweaking, and I look forward to trying that out. But you know, I could use the resources that MariaDB had, the bug tracker, to sort of get an idea of what was going on, all the documentation. I actually fixed it by fixing their indexes. It was the query optimizer was picking up a weird route because they had weird data in their database because of WordPress, which is always weird. But yeah, you know, we had to go to Oracle support for this. You know, I'd have to write them a huge check, and I can't afford that. My customers can't afford that. And you know, even if they could, it's not what we want to do. We want to improve it not just for one person, but for the whole community. We want to make every WordPress site better, every e-commerce site better. You know, we want to store people's data safely. We want to be able to back it up easily. We want good tools to manage it, and that's where, you know, MariaDB has continued and improved hugely on compared to other databases and, you know, other systems. So yes, it's the whole package, really, the whole environment.
Thank you, Dom. That's really encouraging to hear with an open source heart that you share with us at MariaDB Foundation. I suspect that, Søren, you might have some kind of an inside question based on your knowledge of Dom's background. Would you like to pose a concluding question for Dom?
Yeah, that's the concluding question. I don't know if we take question and answer after that from the audience. But our last question, basically, Dom, from Kai and me, is the following. So look, like, you're a real English entrepreneur, you know, and a real English entrepreneur, you know, owns an own hub, like you do in the southwest of England. So, and we need to really make a decision where we do the next physical server fest, which we hope is physical again, right?
Yeah.
So, our idea is to make it in your hub. Can you invite us all?
You are all definitely invited. It's the perfect site, and it's got really good fiber internet. But just don't put the servers too near to the fires or the beer.
Cool, so do we have questions from the audience? Monty has a question. We have a microphone for you, Monty.
You had a bad query. Is it any chance that you could put a Jira ticket for that so I could just test if the new optimizer will fix it?
Yeah.
Sure. And also explain from the MySQL side so we can see what they picked and why. Then we can figure out why it picked. I'm just interested to see that, verify that my code is good.
Yeah, no, I've got the explains, and I've got a lot of query. I don't know if I've got all the data, but
and then we can figure out the data if you can see the data.
Yeah. I'll send you my notes.
Vincenzo, did you have any audience questions? Anybody else? Well, then we'll have to thank you very much, Dom, and of course thank you, Søren, as well, for an interesting discussion on respecting the stack. Thank you.
Thank you. Happy to support.
Thank you, Dom. Thank you, Kai. Have a good day.
Bye.
So the optimizer changes in MariaDB 11 was going to be the next topic happening at this point in time, but we were a bit time zone challenged, so we swapped that presentation. So you have to look in later to Monty's presentation, which has already taken place. And now we will have a lecture about a happy life. Happy life based on, shall we say, a change log of the added features to MariaDB 10, the releases since the last Server Fest, 10, 8, 9, 10. That's up to Federico Razzoli, one of our favorite presenters here at the MariaDB Server Fest, to report on happiness and the backlog of new features. So over to you, Federico.
Hi everyone, sorry, I was having a problem with audio and I had to close YouTube, obviously. Just 1 second. Great, I hope you hear me well and
we do
see my screen again. Great. Okay, so as you said, my talk is about recent MariaDB features that were added in the recent versions. So this is the usual slide about who I am. For whoever doesn't know me, I'm Federico, and I work for Vettabase, and that is my email. I love emails, so if you have any questions about anything I'm going to say or any comments, please feel free to reach me. So why this talk, first of all? Well, features. MariaDB has great features. They implemented a lot of wonderful features recently, but the features you don't know, surprise, surprise, will not help you in any way. Of course, I'm talking about proper features and not just optimizations, because optimizations theoretically help everyone even if you don't know about them. In reality, well, you should know about them anyway for various reasons, but still. But here I'm talking about those kind of features that you use on purpose, okay? My point in this slide is that even if MariaDB is great at creating new features, it's sometimes a bit less great at advertising them and letting people know these features. But you know what? Complaining is cool. It's outstanding. I do it all the time because I'm Italian. But yeah. But there is something better we can do sometimes, which is contributing. And actually, MariaDB has a wonderful knowledge base, which is a public wiki. The contents are covered by open licenses, a Creative Commons license, and a GNU free documentation license. And there are also pages in the wiki itself about how to contribute. So it's something that everyone can do. And here I wanted to show an example. Actually, I made these changes exactly to show that anyone can do them. These refer all to the same page, which was the page about the except syntax. I noticed that there were some things missing, and I made these contributions. First of all, I noticed that it wasn't mentioned that you can use values instead of select on one side of the except. I shown an example involving the sequence storage engine. I fixed the example. I added the offset fetch syntax, which was missing, but actually it can be used with except. And I completed the syntax of order by. So my point is not that I'm great. My point is that this is not rocket science. Anyone can do it. And if you think you can't, it's just because you've never tried, really. So, that said, MariaDB versions. Okay, I'm not going to talk about the prehistory. I'm not going to say that in the beginning MariaDB used to follow the same patterns as MySQL, blah, blah, blah. No, let's talk about recent things. The latest MariaDB, the latest MariaDB long-term support version is 10.6. And it will be supported until July 2026. I think that sometimes MariaDB extends the life of a version if many people are still using it, but of course users shouldn't rely on this. After 10.6, some short-term support versions were made. 3 of them are stable, as you can see here. One is alpha, and the latest one is a release candidate. As you can see, basically, the alpha, beta, gamma release candidate stable pattern still exists, which is good because even if a version is short-term support, you should know if it's stable or not. But the big difference is, of course, STS versus LTS. Theoretically, only long-term support should be used in production, because short-term support versions have support for only 1 year. Well, based on what is happening now, I can probably safely say that by that time another STS has been released. But anyway, STS are, of course, mainly good for testing features. That is their purpose. Give feedback, learn features when they come, and not having to learn them altogether when a long-term support version is released. Actually, if you want to test and give feedback, there are also specific binaries that MariaDB produces. Binaries to test a single feature, but I'm not going to talk about that. Just being aware that they exist, and maybe one day you want to try them. But anyway, I said that theoretically STS versions shouldn't be used in production because actually I think there are cases when it can be more or less safe. For example, maybe you want to use only a specific feature, which maybe is useful for data analysis. So nothing prevents you to attach any replica to existing production servers using an STS and take advantage of the new feature without creating any problems to the other servers. So, here in this talk, I'm going to talk about the most important features included in these STSs. So features that are not yet in a long-term support version, but they will come. But you can expect to see them in the next long-term support version. Most important, according to me, of course. So you can, of course, disagree. I'm totally okay with the disagreement. When people who disagree discuss, at least one of them should learn something, probably both of them. Anyway, I'm going to discuss the features not in a chronological order, because I think it would be useless. I'm going to discuss them in a logical order, grouped by the macro areas that they belong to. And I will not assume that everyone is an expert, but actually the people that you can see in the image are actually experts. But I will assume that anyone can watch this talk, and I will explain things. So if you never used MariaDB, or if you do it at a superficial level, maybe don't worry. I will try to explain things that are not obvious. So let's start with the features. And let's start with the replication area, replication and high availability. So I selected 3 features in this area. As you can see, for each feature, I made these tables, right? So you can see in the first column what the feature is. If you want to go deeper into understanding the feature, you can see the ID of the Jira task. Fortunately, MariaDB has a public Jira account, so we can see what they work on. And looking at the tasks actually sometimes is very useful, because sometimes you get more information than you can find in the documentation. Again, you can contribute in that case. And you can get the context, and you can know the reasons why certain choices were made. And then, of course, I put the version of the feature. So let's start. And the first one is what was called lag-free alter table. So, first of all, previously alter table was executed on the master first. So in a replication chain, first the master did the whole operation, and then it was started by each replica. This means that while the replica do the alter tables, the master is probably writing to that table, and maybe the replicas can't because there is a metadata lock on that table, for example. So these kind of things tend to block replication. And well, if an alter table is very fast, maybe it doesn't matter, but sometimes it can take hours. So this lag-free alter table basically makes everything more fluid, because now the master starts to execute an alter table. It replicates, it sends this event to the replicas saying it started to do an alter table. The replicas can also start. And then they will basically do it at the same time. Actually, it could even be that replicas are faster than the master for so many reasons. In that case, well, the alter table will only be finalized when it's completed on the master. If alter table fails on the master, then replicas will stop the operation. So basically, this simple mechanism, well, this apparently simple mechanism guarantees that there is consistency between master and replicas. The next feature is about the allow list for SST and SSI for Galera. As I said, I'm not assuming that everyone who watches is an expert, so I'm going to even explain what Galera is. Galera is basically virtually synchronous master-master replication for MariaDB. Well, MySQL users know it as a plugin probably, but in MariaDB it's built-in. So basically you have it. And the SST and SSI are important mechanisms of Galera, because when a new node joins a cluster, it is sent an SSD, which means a snapshot of the whole database, of all databases actually, from another node. When a node is restarted or maybe crashes and then is restarted, it will hopefully receive an IST, which is an incremental snapshot, only the changes that it missed during this interval of time. Of course, if it stayed down for too long, probably the Galera cache is not big enough to contain all the changes, and then it will receive a complete SSD. But anyway, that said, the point is a node can receive the data. So it is a good practice to keep Galera in a private network, because otherwise maybe an evil attacker will set up a new node, and this node will connect to the cluster and will say, "Hi guys, I'm a new node and I would like to know anything." It is not ideal, but usually running Galera in a private network or virtual private network is enough. But anyway, there is this nice feature that has been added. Oh, sorry. This nice feature has been added. It's an allow list of IPs from which a new node can connect. So basically, you have this variable, you put a list of IPs here. Of course, if a node is new, you don't necessarily know its IP when you configure the servers for the first time. In that case, you will have to add two addresses here for the new nodes, and it requires restart. But you can do this one node at a time, so it's not going to be a huge problem. It accepts IPs, both versions, 4 or 6, not host names. And you can also query the WSREP allow list table in the MySQL database to see which IPs are in the allow list. Of course, we're talking about IPs, so theoretically this feature maybe is not super Kubernetes friendly, but on the other side, I don't exactly know why people want to run databases on Kubernetes, so maybe this is a good thing. Oh, and the other thing is still about SSD. Basically, the problem was debugging SSD problems could be a bit hard because cryptic errors were printed in the error log. Now we have this new file called the WSREP status JSON. The format is readable for both humans and machines. And this is an example copied from the documentation or maybe from a task, I don't remember. Anyway, you can see that it's JSON, but it's also well indented. So again, it's very readable. You have this status object, which can be checked periodically, for example, by an agent to check if there are problems. That is useful. And if there are problems, you will have this array of errors and this array of warnings. So let's see features about performance. These are the ones I selected. Basically, inserts into empty tables are faster. There are ascending and descending indexes, JSON histograms, collections, some collections are faster, and the InnoDB log file size is now dynamic. I can't see you anymore, so please let me know if if there are any problems. In the meanwhile, I'm still talking. So let's start from the inserts. Inserts into empty tables were already made faster in 10.6. But in version 10.7, more optimizations were made, especially for tables that already had indexes. Well, it was actually a good practice to populate a table before creating indexes, because this is faster. But if you can actually populate a table that already has indexes, well, you know that when you end populating it, you already have indexes, so it's ready to use. It can be convenient sometimes when you are uploading data into a specific table into a server which is already used in production. Mind you, this works with empty tables, so you should use one insert, one multi-row insert, so a single insert statement that inserts many rows. Because if you use many insert statements, basically after the first one, the table is not empty anymore, right? I don't know if it's intuitive or not, but it's worth highlighting. Let's talk about indexes. Well, basically since the beginning of time, more or less, MariaDB support.
So, Federico, we actually have an immediate comment here by Marco on one of your items.
Yes, yes. Regarding inserting into empty table, the initial implementation was like you said that only the first insert statement is done in a special way, but then there was a bug report that this changes the locking, so we made it depend on some parameters. You have to do set unique checks equals 0 and foreign key checks equals 0. This is what the MySQL dump is using when it's generating the SQL. So currently you have to explicitly enable this optimization for inserting into empty table, and then you can have multiple statements inserted into it inside this transaction.
Okay, thank you for the correction. I didn't do a lot of testing here actually, so thanks for letting me know and letting everyone know actually. So back to the indexes. Basically, MariaDB is supported for a very long time. Well, it always supported the ask and desk syntax when creating an index. You could do something like this, alter table, blah, 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 add index, and then column list with desk and ask. But until now, this syntax had no meaning. So indexes were always ascending. But now actually it works. So if you specify, if you write an SQL statement like this, you will have an index containing date column which is descending and then author which is ascending. So actually you can mix the two sort orders. And this is very important because this means you can optimize queries like this, because this query that you can see here in the example will be able to use this index. But actually, even if you invert both the columns, it will be able to use an index. But it will not if you have both descending columns in the index or both ascending columns in the index. So let's proceed. JSON histograms. I said before that I will try to explain everything so that everyone can understand without being an expert. This is actually a bit technical, but I will try. I will try to explain everything. Basically, we need to explain one concept first, which is statistics. Statistics are estimations about data distributions in the tables, in the indexes, and in the columns. And they are used internally, of course, by the query optimizer. Basically, based on this information, the optimizer decides how to execute a query, in which order it will read the tables, which indexes it will use, or maybe it will decide not to use an index at all, and so on. Now, in previous MariaDB versions, so in 10.6 or before, MariaDB already implemented engine-independent statistics, which means that statistics are written to system tables, and they can be used for all tables, any storage engine. Storage engine dependent statistics still exist, but we can also use engine independent statistics. And this is also important because probably some storage engines give poor information about data distributions or no information at all. Probably this is especially true for special storage engines like Connect, for obvious reasons, not because their quality is bad. And then histograms. Well, histograms are...
Federico, there's 3 more minutes until Q&A then, but as you know.
Really? Well, let me finish some of the features then, and we will not reach half of the half of the planned talk, but the slides will be available, I guess, so people can still see them. Anyway, just to finish, basically, histograms are used to merge the values into groups of values or ranges of values. And then there are more specific statistics like, okay, this range has X values and epsilon unique values, for example. JSON histograms are more accurate and more granular histograms. They are not created by default. They are used by default if they exist. But to create them, you need to do it explicitly because it's a lot of information to check and to store. So you can use this SQL query, which is analyze table persistent for all, or the second query where you basically specify the columns you want to analyze. Collections, well, this is actually an underestimated problem, I think. Collections, well, who watches this talk knows what collections are, so let me explain very briefly. If character sets are basically the set of characters that you can use in a column, collections are the rules to sort those characters, for example, in an alphabetical order. Some collections are more simple, others are more complicated, some are case insensitive, some are not. There have been some optimizations in some collections, and in my understanding, this is especially true for collections that are a superset of ASCII. Basically, they now order characters, not one at a time, but in groups. If I have time, I'll just explain this, which is basically InnoDB log file size is one of the two most important performance settings in MariaDB. If it's not big enough, the writes to your database will be slow. But until now, changing it was risky and not really recommended because it involved making sure that MariaDB was shut down properly and then deleting the log files of InnoDB. Basically, I wouldn't do it without a very good reason. But now InnoDB log file size became a dynamic variable, so you can change it at any time, even if MariaDB is running. If I have only 2 minutes, instead of discussing the next features, I will only show the tables. Just to say very briefly that now we have 2 nice data types, which are UUID. Why is it important? Well, because basically you can insert a UUID with the same syntax you used before, but instead of taking 64 bytes because it was a string, it will take 4. And you have a init for type. Init 6 already existed, but nowadays IP4 is still more common. And then, very quickly, there are some new functions. S format can be used as a powerful but very friendly function to compose strings using interpolation. Natural sort key is used to sort strings in a way that is friendly for human beings and not for machines. This is very nice when you order strings that are made of, numbers, separators, and so on. Random bytes, which you can use to generate random bytes and then convert them to any data type you want. JSON equals is basically very nice to compare to JSON documents, because in MariaDB, JSON documents are actually strings, and when you compare strings, spacing and the order of keys count, for example, with JSON equals, these things are ignored. And then there were a couple of enhancements to JSON path used in some functions. Basically, the array notation was extended with negative indexes and with range syntax. And since I already exceeded the time that was allowed to me, I'm stopping here. But I hope to hear questions, of course.
So thank you, Federico, and thanks for the very good short summary of those tables. I think we got the gist of JSON equals and UUID and all of that. So, Vincenzo, is there any pent-up list of questions here, or did we hurry up Federico in vain?
No, we're okay. We're just in time for next talk.
We're just in time for next talk, but do we have questions? And in the audience?
Well, I have one. Federico, thank you for mentioning alter. So that is, to my view, a very cool feature, and actually in parallel at all. So MySQL, our competitor, doesn't have it. How do you see it could affect, positively to us? Could you answer this?
Well, yes. You mean from a user point of view, right?
Right.
Well, I think it's very important because it solves a huge problem. Because well, alter table had two problems. One is that it's locking, so it's locking on the master itself. Well, it's not always locking. Nowadays, most operations are not locking actually, but some are still locking. So, of course, a user who runs it on a big table needs to be sure that they are not running a locking operation, or they must use a tool like PT Online schema change. But I know that you guys are already working on a task that will solve this problem. The other huge problem is more related to replication, because alter table can make replication lag a lot. Of course, not always, but in some cases it does. When it happens, well, sometimes people didn't expect it, and then they start to panic. So I really believe this is a killer feature. I don't know if this is if I'm answering your question, actually.
I think you did, and that I think you gave a really good presentation on how to be happy with the incremental set of features from the last couple of releases. So big thank you to you for doing the advertising that MariaDB we don't evidently do ourselves. Thank you.
I hope no one took offense about that.
I don't think we did.
I really want to improve this. Thank you, everyone.
Thank you. So now we have another happy presentation of the incremental nature. So this is about new optimizer features in MariaDB releases before 10.12, if there ever will be a 10.12. This is Sergei Petrunia with a select statement, something related to date is not null and interval 1 year. Can you be a bit more specific about that one, Sergei?
Yes. The title of this talk, for those who already think in SQL. Yeah, the scope of this talk is to talk about optimizer features which have a release date, which are in a release already. And the release date is basically less than 1 year, in the past. So basically these are the features which we haven't talked before at any conference. Well, it's roughly 1 year. There was a talk at FOSDEM, but I'll get to that. Yeah, so we had a talk by Monty, who mentioned that he spent last year fixing the cost model with help from other team members. And that's probably the biggest single development that's going on. But besides that, things have been happening in the optimizer as well. So this talk covers like everything else that happened. Yes, so we will go in a chronological way, going from earlier releases which are already stable and towards newer, which are is still not stable, but already there. Yeah, so 10.8 was stable in May this year, and the query optimizer features are, like Federico mentioned, JSON HB histograms. It could have a talk on its own. I can only refer to that talk at FOSDEM, which covered them. Reverse ordered index support received. Also was reverse ordered indexes got support in the optimizer. Again, probably wouldn't cover that here. And one thing which we haven't discussed publicly is that JSON produced by the query optimizer is now valid and processable. And let me cover that in detail. Now, query optimizer in MariaDB produces JSON documents. There are several commands: explain format JSON, analyze, and optimizer trace is a big JSON document. Reasons for using JSON were that it's human readable, maybe not the most readable, but at least well understood syntax, and that it allows for automatic processing. For example, you can extract parts of the trace you are interested in, and so forth. Now, the JSON, again, a refresher for those who do not remember it by heart. JSON has two data structures: arrays and object. Array elements are not named, and object elements are named, but not ordered. What if the object has duplicate names like here? This will still be a valid JSON, but you may get gotchas in processing. Like some tools will actually process both for and bar separately, like two members. Some tools will just use the latest one, and some tools will concatenate. So if you get two members with the same name and their values are objects, you will get just one member with the value of object, which is a mix of everything that was in both. And why is that matter? Because our explain output was exactly like that. So when we try to develop some automatic processing for explain output, we were immediately hit that we were getting like a soup of all different explain lines together. And I apologize for everyone who has wasted time trying to do the same. But now this is fixed. Now there is actually an array, so the members are not mixed. And this allows for automatic processing of explain and analyze output. Yeah. Okay. Yes, so starting from 10.8, all JSON documents are processable, and the intent of that is that now it's possible to develop tools. Like the tools that initially I had an idea about are that explain analyze could benefit from a visualizer, something that would highlight the heaviest parts of the query. Other databases have that, like Postgres has that, where you can paste explain, and it will show you which part of it was, which parts are the heaviest. We could benefit from something like that as well. Well, for optimizer trace, we would benefit if there was a script that would, optimizer trace is a big JSON document which describes everything that the optimizer did about that query. It describes all of the possible paths or possible plans that it considered but didn't pick in the end. So what would be useful if we had a script that would extract just information about the plan that got picked, but with all the details. It will be much more detailed than explain output. Yeah, so and now with parsable JSON, that's possible. So it's not a breakthrough in database science, but I think this could have a fairly large impact on us. Those who work on optimizer. Now going to the next version, 10.9 was stable since August this year, and it got 3 features closely related, or if you call them one feature. Again, there is not optimizations, but rather observability improvement. In case people don't remember what's show explain, MariaDB has this show explain command which allows you to see explain of a running statement. Suppose you've got a long query running in one connection, you could connect with another connection, do a select from process list to find out the thread ID of the first one, and then you do show explain for and you see what query planet is running. And this has proven actually practically useful when there were some people had in production surprises about what query planet was executing, and this diagnostics was very helpful. Now in 10.9 show explain is improved. Now we support show explain format JSON, which has more information. There were some technical difficulties to doing that in previous version. That's why we didn't support it, because you need to reach out to grab the data from another thread, and it wasn't fully safe to do that for all kinds of data, but this problem has been resolved. Once we got that, we could actually add compatibility syntax with MySQL 8, because they've named it show explain for connection with format. They supported format JSON. Now I think we were asked pretty much at every conference whether we could support this syntax. So hopefully this is the first conference where or meeting where somebody doesn't demand that we implement this. Now we can have unified syntax support.
One way.
Sorry?
One way. MySQL doesn't support ours.
Yeah, MySQL doesn't support our. Yeah, yes, but there is more. If you, I've mentioned analyze. In case somebody doesn't work with it, analyze shows explain and with execution data. So it runs actually the select, and then it gives you explain output and also the data that it observed while running the statement. It has format JSON form, which has a lot of details, and this is very useful for optimizing troubleshooting. The output looks like this. Here is this is a subquery which was run once. It took this many milliseconds. Here how many rows we expected. Here how many R shows real, like how many we've got. And this shows again which percent will be expected to be left after where condition. This shows what we've got, and so forth. And our experience was that this tool was of tremendous use when troubleshooting. Basically, pretty much every support team escalation to us starts, well, they already learned that they need to provide analyze format JSON output from the start. Yeah.
It was really helpful for me when I was checking the optimizer.
Mm-hmm. Yes, so this is helpful, but there is one big if. You actually need to be able to wait for the query to finish to get the analyze format JSON output. Sometimes the queries are like this, and that's only a fragment. And you start, and it never finishes. And you never get the analyze output. And if the query has constructs with large potential for errors, for example, like derived tables with having, where optimizer doesn't really know how much will be left, or say many table joins where optimizer error is multiplied, so you really have, looking at explain, you really have no idea how much time. Or this particular thing has subqueries where, like looking at explain, one sees that like, okay, this subquery will take probably 5 minutes, which would be fine if it's run once, but if this query is executing it like millions of times, that's not okay. So all of this basically, and since you don't get analyze, they're really like stuck for, well, it took days to attempt to analyze. So we have implemented this feature. And now you can do show analyze as well as format JSON for thread ID. And it shows you analyze output as if the query stopped it right now, as if the query has finished the moment you ran it. The new member here in red is query time in progress methods, how many milliseconds we have been running so far. Well, here, here there are members. In this particular case, the target query is running simple select. So you get R loops, R rows, but you don't get the timing information. That's because by default, in default setup, the query execution does not time row accesses, because timing these fine granularity events like row accesses has overhead. So by default, the run is not timed and you don't get timing information. But if the target is running analyze, then timing will be collected and you will get timing and show analyze as well. So if you get the query that runs forever, you run analyze format.js or just analyze in one thread, run show analyze in another, and that way you will be able to see where the time is being spent. Yep. So to summarize it, it gets analyze format.json for a running query, useful for troubleshooting. You can run it repeatedly several times and see how the query is making progress, where it's which rows are enumerated, and get the clue about the how much is it going to take. If it's big report queries, sometimes it's really helpful to just get the clue about, is it halfway done, is it almost done, or what are our options. Yeah. Go back a bit. Yes, well, one needs to be careful about interpreting the output. Here, R loops is 1. It shows it is the first iteration. This is first iteration. And with low R loops, one needs to take into account that the last iteration is not complete, so you get current data. Basically, in rows, you get the average between however many rows were in the first run and however many rows you've got in the second run so far. So for low values of R loops, one needs to be careful about interpreting it. When it gets, if it is something that's executed many times, this effect will gradually die down and you will just see average. Yep, so this is the tool. And this is already in a stable release. So moving on to 10.10. 10.10, now we started to talk about optimizer features, optimizations, finally. Table elimination works, improved optimization for many table joins. And table elimination, yeah, here is again refresh about table elimination feature. If you have a normalized schema with optional attributes, like here we have user, and table of shipping addresses, where a user may have optionally shipping address or may not have. And one can create a view to get all of that. You use left join because some users have shipping addresses, some don't. And then you can query the view, and here you see if you get the address column, you see that the address table is accessed to read it. And if you don't get the address column, then table elimination optimization will figure out that we don't need to read shipping address at all, and will remove it. This is actually important because, well, I saw cases where there were like dozens of these optional attributes. So, and only minority were actually read by the query. So this can save a lot. But now we come to extension of it. Sometimes a user can have something which it has multiple of. For example, here are user and orders. User may have many orders or no orders. And we want to show with the user all of its total, the amount of orders he has made. And here table elimination wasn't working, so it was just computing totals for every user enumerated, which is not an efficient use of time. But our new developer in the optimizer team, Oleg Smirnov, took this task, and he has added a feature where we can eliminate, has added support for table elimination of derived tables as well. Now it looks like this. If we do select and we select the totals, we see that there is query plan has nodes to compute the totals. If you don't select totals, well, order totals is eliminated. So again, this is based on sort of customer queries we saw where we saw a lot of extra computation being done. So summary table elimination, applicable for inside the order join, can eliminate unused tables, but starting from MariaDB, we can also applicable for derived tables with group by, so which compute totals. For many table optimization for many table join, this was based by a bug report well, Monty was fixing it. The idea is that if you think of a n-way table join where we are joining multiple tables, MySQL and MariaDB optimizer work like this. It builds only so-called left deep query plans. So there is a sequence. It starts with one tables, will join more tables. Like here it will start T1 and at T2, T3, T4. And the total number of combinations to consider n factorial. And basically the optimizer will try to prune away that space because we can't enumerate this many for numbers larger than, say, 6 or 7, or depending on where you decide to stop, certainly not 10. And here it shows like if we see that adding T4 is already not promising or is already worse than what the cost is already worse in the query plans it was so far, the optimizer will just do so-called pruning or just decide not to explore this path forward, not to build query plans. Here again, this is depicted another branch that was pruned away. There are two options to prune it. Two parameters. Optimize prune level declares how aggressive the optimizer should be. I think the default is still, the default is still 0. And the extra feature is that there is now, in addition to value of 1, there is a value of 2, where the optimizer would do more aggressive pruning. And there is an extra parameter now, optimizer extra pruning depth, which denotes about at however many tables this extra aggressive pruning will start to come in effect. Well, I have a whole, I think, separate presentation denoted just to that question, just to this description of this particular feature. So here we had a really like bird's eye view of it. But feel free to check this out. Moving to 10.11. 10.11 is alpha. Well, there is only one optimization that we've got. It's again based on user input. Queries reading from these tables about stored procedures and their parameters were slow because they like it optimization, and the executor would just parse every routing before deciding whether it matches, whether we need to return it or not. And this is important because Java connectors queries these tables, so it would happen on pretty much on every incoming connection. Well, optimization was added. The idea is basically just don't parse the stored routing if it doesn't match the where, so just parse the routing that we are interested in. Another addition is now analyzed from JSON shows the time spent in the query optimizer. Again, this is based on the input that sometimes you can, particularly with this, when this pruning is not set up correctly, the optimizer can spend a lot of time looking for a query plan. So now you can see, analyze will clearly show how much time we spent. How much time was spent there. Yeah, so for the summary, that's pretty much it. Green one are released version, JSON histograms, processable JSON, show explain, show analyze. These are in stable. RC has table elimination for derived tables and improved optimization for many table joins. This is in 10.11, and Monty has covered what's coming for 10.12. Well, and yeah, somewhere here we are active users eating our dog food and using the optimizer trace heavily to analyze the support issues. So we are improving. When we see something is missing there, we improve it. So first, don't be surprised when the trace is somewhat different between versions, minor versions. It not necessarily means changes in the optimizer. Sometimes it's just improved coverage.
Especially in 10, 12, or 11.0.
Yeah, so that's it. We're ready to take questions.
Perfect. Thank you, Sergey. So I think Monty is eager to have a first comment or question.
Actually, you mentioned improved optimization for many table joins.
Yes.
Actually give us some data of how much that helps would be good.
Well,
or should I take it?
Yeah, I don't have it in my mind at the moment. So if you remember.
So the bug report said that this takes forever, and forever was more than 10 minutes, and I got down that to sub-seconds, and that's what that is about. So now we can handle, in many cases, very, very complex joins with many tables, but assuming there's some kind of indexes. But
do you remember how many tables were there?
I think it was 20. 20 in the grid optimizer test that I took from MySQL to verify our code, and our code was about twice as fast, because we actually do more than they do. But it basically solved the issue for the customer.
It was mostly affecting highly symmetrical queries where you can have YAQRF access, say, to where there are many tables joined with YAQRF. It just kept on enumerating these YAQRF variants in which order to put these tables, because none of the join order was particularly different, so it couldn't chop them off. And this improvement makes it sure that it doesn't spend time enumerating the nearly the same join orders.
So I would be curious whether you at Wikimedia Foundation would already see some patterns about issues that you've had. Any comments your side about this?
No, I think like all the improvements that have been done, and especially all the new features to represent the data, the optimizer output data is gonna help a lot, because we always struggle to to read the optimizer output, and sometimes when we fill out the bugs, we just like, okay, we're going to send this piece because we think it's relevant, but sometimes Sergey asks for some other parts of the optimizer output because it's not really clear for us.
So for those looking to build the tools on top of Optimizer Trace and Analyze, do we have like a sort of JSON schema for how the format is supposed to look? Or are we going to do that in the future?
Well, I have the mic, okay. For Analyze, I think we could have one, because Analyze is more or less, how to put it, stable, more stable. For Optimizer Trace, it's somewhat harder, because it would be hard for us to commit to keeping the trace in its current shape now, because we are looking at making some improvements. And the problem with Optimizer Trace is basically a structured log of what the optimizer did. If we commit to keeping the optimizer trace the same, it basically means we commit to not changing this code in the optimizer, which we don't really want to do, because we don't know what we will develop and how that will change. So it needs to be there needs to be some careful design about how do we expect that the structure of our code in the optimizer might or will not, where it will and where it will not change. So this is less likely. But maybe we will come up with some sort of conventions. It wouldn't be a JSON schema as in schema, but some guidelines about what is going or not going to change.
We can say that rows means this, and yes, some certain labels that are always well defined. That already would help.
Yes, maybe also some convention about what means that we have discarded this option here that we were considering or not, something like that. Yeah. But analyze is much more stable, so we probably can, again, I'm not sure whether we can set it as a schema because we might have some extra plan nodes in the future, but at least analyze has a more chance to remains where we can come up with a schema, but we don't have it at the moment.
Well, I'm sure we can define a schema for a version at least.
For a version, definitely yes. Well, but I guess somebody coding against that would want forward compatibility, and yeah. So.
And even for a version, things can change. We notice we really did this one. This is a developer tool.
For optimizer trace, I agree. For analyze, I think it makes sense to think of the end user a little bit more.
Right.
The DBA in this case.
Right. Like rows and real rows and total time MS are already pretty much set in analyze. Mm-hmm. Yeah. Well.
And you plan to add costs also.
Yes.
Here.
No further questions? Then thank you a lot, Sergei Petrunia. So now for one of the very last presentations of today, it's back to university time, to the basics of multi-version concurrency control in InnoDB. I think you cannot get much more basic and fundamental than that, and you cannot get much better expertise on explaining this. So Marko Mäkelä, over to you.
Thank you. So I will be explaining how multi-versioning has been implemented in the InnoDB storage engine. So I'm letting Wikipedia help me because I helped Wikipedia fix things that I wrote. That's what I got this badge for. So this is the definition from Wikipedia. Multi-versioning or concurrency control, or MVCC, it provides point-in-time consistent views. And read transactions under MVCC, they typically use a timestamp, or in case of InnoDB, they use a transaction ID to determine what state of the database to read. And then it will read these versions of the data. Read and write transactions are thus isolated from each other. Well, the Wikipedia says without any need for locking. Okay, Heikki Tuuri would agree. He says that locking is the transactional logs. But then we do need some internal mutex or read-write lock in the code to keep the read views consistent with transaction commits and so on. Those Heikki called latches. So it's okay. It's not doesn't need locking, but it does need latching. And yes, it introduces a challenge how to remove the history from the database, the old versions that are no longer needed for any, even the oldest active read views. And a drawback of this system is that we have to store multiple versions of the data objects in the database. Now, how does it work in InnoDB? We have, like I said, we have transaction IDs, and then we have a read view object that has it has a range of transaction IDs. Anything that is older than a so-called minimum transaction ID at that point, those transactions are considered to be committed. And then we make a copy of the maximum transaction ID at the time of the corresponding to the read view. And anything newer than that, at that point maximum, will be uncommitted. And then we have a set of transactions that may have been committed, depending on timing. Well, you cannot know it in a general case. So we have a collection of transactions IDs that are considered to be not committed. And then in addition to the read views that are used by user transactions, we have a special read view called the purge view, or purge system view, which gives permission to a background task to remove old versions from the database. And since MariaDB 10.6.11, we have another view in the purge system, which says that anything up to this transaction or up to this view must have been removed, and any undo lock records that are visible in this view, they are no longer safe to access. But anything older than this, anything that is between those two purge system views, they are safe to access. The undo lock records are safe to access, because only at the end of the purge batch we are actually freeing the undo lock records. And we have a special transaction ID 0. It has two meanings. One is that read-only transactions do not get assigned a transaction ID. Those always have a transaction ID 0. And since MariaDB 10.3 purge is clearing the history even after insert, it is zeroing out the transaction ID in the records. So 0 in the records means that there is no history, and MVCC doesn't have to look up the transaction, is it still active or not. Or actually not MVCC, but the locking checks don't have to look it up. Read view creation is related to transaction isolation level. At the default level, repeatable read, InnoDB creates a read view on the first row access inside a transaction, or if you have an explicit statement start transaction with consistent snapshot, that is the point when the read view is created. If you use read committed isolation level, then the read view will be created at the start of each statement. And if you use read uncommitted, then there will be no read view, we will just read the latest data. And if you use serializable or if you have a locking operation, then the read view doesn't matter. I can't remember if it's created or not, but it shouldn't matter. We are reading the records under locks, and then we are basically seeing the latest version, and that for that version the lock must be available, so it must be a committed record. So how is this implemented inside InnoDB index trees? We have InnoDB is an index organized table engine. It means that unlike, for example, MyISAM, it is storing records together with the primary key. It's not a heap organized table. It's not appending records to a heap like MyISAM, but it's actually the clustered index is a B tree. And inside the B tree we have the key is the primary key, and then we have two system columns or fields which are hidden from the upper layer, the transaction ID and an undo lock pointer, and then the rest of the columns. The transaction ID is set by the transaction that is inserting or updating or deleting the record. It identifies the latest transaction that has touched the record. And if there is no history, then this field will be 0. And then if we have an active transaction, then, or a transaction that is visible to some reviews, we can follow the history by looking up the undo lock record pointed to by this second field rollback pointer. And based on that rollback pointer, we can construct a previous version of the record. And that previous version also contains these transaction ID and rollback pointer records. So you can go back in history by looking up the previous undo lock record and so on until you reach a point where the purge system says that you are not allowed to access this undo history may have been removed. But actually your read view should be saying that I don't see that history, it's visible in my read view. And delete and update of primary key, they will set a delete marked flag in the record. So if you are updating a primary key in a table, it will be implemented as a delete of the old record and insert of a new record with the new key. In secondary indexes, we have less information. We only have the secondary index key, and then we have the primary key columns that do not occur in the secondary index key columns. So based on this, we can't really know if the record exists in the table or in the read view. In secondary indexes, we have, for a single cluster index record, we can have multiple secondary index records if the key columns of that secondary index were updated. So if you are updating some indexed column to a different value, you can have multiple rows for that primary key value in the secondary index. Yes, Sergei Petrunia, I have a question.
How does the scans work? If I'm in a transaction and I do how do the scans work? If I'm in a transaction and I'm reading through secondary key and I want to only key columns, does it mean that InnoDB will still go to cluster it, keep under the hood to check if I should see what I with the
yes, for index scans there is one optimization is the index condition pushdown. We can evaluate the secondary index key and the primary key columns. We can evaluate if they match the condition. If not, then we will ignore. And then, as you can see from the rest of my slide, I haven't explained it yet.
Okay, sorry.
So, in a good case, if the maximum transaction ID of the page is old enough, then we can already trust this record. But if the record in the secondary index is delete marked, or this maximum transaction ID is too recent for our read view, then we have to check if that row really exists. So this is an additional cost, and it's actually rather hard to predict the impact of this cost. And we have this, may have heard the term purge lag, or the history list length. If the InnoDB purge of history is lagging behind a lot, then you will have a lot of garbage in the secondary index pages, and then you may have to do these extra lookups for the clustered index record to see if the row is visible. So we have to look up the primary key in the clustered index, and then we have to check based on the transaction ID and undo log pointer in the clustered index. We will try to construct, do we find a record that corresponds to this secondary index, and does that record exist in our read view? So that's rather expensive.
Marco, reference to clustered index record. If a record under the secondary indexes, does it refer to the clustered index record, right?
Yes, Andre. In the secondary index records, we have the secondary index key, and then we have the primary key columns. Yeah. So always, or very often, we have to do this matching between secondary index records and primary key records.
So the record is clustered index record.
Yes, clustered index just is a term that we use for the primary key index. If there is no user-defined primary key, then there will be a generated primary key, DB row ID. But internally, we will have that. That's then a 6-byte field hidden from the SQL layer. So to illustrate this, I created a simple example, and this will go on for most of the rest of my talk. Simple example of creating a table, 2 transactions that insert and delete and commit, and then another transaction does insert and rollback. Table will be empty as a result. Can you spot any race conditions? Well, you will internally inside InnoDB you will find out that there are some. So
one question, are the transactions executed in parallel or sequential?
It is all sequential.
So just run these in one client?
Yes.
Okay.
So first step is that we create a table. Inside InnoDB it's created as 2 B trees. I'm showing the B trees as a table here, in table format here. These are showing only the leaf level records. So we create a cluster index which has the primary key column A, and then we have this system columns, transaction ID and rollback pointer, and then the rest of the columns, in this case it is the column B. And then we have the secondary index for the index B, its key is B and primary key is A. Then we are inserting 1 row to the table. It will insert a row in each index. It will start by inserting an undo log record that says that I inserted this primary key. And based on this undo log record, we will be able to roll back to delete the row on rollback. And once we have inserted the undo log record, we will actually insert the record into the clustered index, and then in a separate mini transaction we will insert a row into the secondary index. Mini transaction is something that is combining modifications to data pages inside InnoDB. So a single row operation consists of multiple mini transactions. That has been a topic of an earlier talk of mine. And then next statement is that we will delete that row or all rows from the table. So the record will be delete marked. It will not be deleted straight away because, well, in this case, no other read view can see the record, but But it could be that if it had been a separate transaction, then definitely we couldn't delete it straight away, because some older review might still want to access that data, or the earlier version of the database where the role still exists. So deleting is a special form of updating. It's updating a special delete mark flag in the record.
The secondary index page is not actually changed at this point.
It is, the record is delete marked in the secondary index.
Also?
Yes, that's what the gray color is indicating here. So also in this case, the delete will first write the undo log record, and then it will update the cluster index record, and then in a separate mini transaction it will delete mark the secondary index record. So between those phases, another transaction or thread could access the secondary index and still see the record that was not delete marked at that point. We have the page latches protecting this, but this interleaving is also there, and code has to take care at that if it has to consider if it is really visible. But actually, if something grabs the page before we update it, then it will see the correct data. The maximum transaction ID will not be updated on that page yet, so it can still trust the record in its review. Okay, then finally we commit the transaction. Now at that point, we already have the first race condition. Because there are no other if there are no other transactions in the system, after this commit, the purge can delete those delete marked records, but it doesn't have to do that. It depends when it gets around to it. But we will assume now that the purge didn't do anything. But basically, it could be that after this point, the table is empty already before the next transaction starts, or does its first operation. So now we assume that there was no purge before the second transaction started, and it inserted the first row. So now it updated this delete mark record. The history is still there. The undo log record that it wrote contains the old transaction ID and the old undo log pointer, so that MVCC can fetch the old version before this transaction started. In case we had something, in this example we can't have because there was no commit between the first insert and delete, but you can imagine that in some other case it would be possible. So we have updated the internal feeds, and we also update this field B from 4 to 5, because the old version, the delete marked version, had 4 in that record. So it's logged as an update of the record. And in the secondary index, we will insert a new record with this value 5 in both columns. The old delete marked record in the secondary index is still there. And now, between the rollback and purge, we will again have a possible race condition. I will show the possible interleavings there. It could be that the purge already removed the history at this point before the rollback was executed, if the page latches are available. If there was some delay on the client side before the rollback command was issued, it's very possible. And then after this, rollback would have to delete both records from the table. So it first removes all the records from the secondary indexes, and then as a last step, the rollback removes the cluster index record. And because in this case the purge has already consumed the old version of the record, rollback must delete this cluster index record. Then let's see the other possibility. So we had this possible race condition. In previous case, we assumed that the purge removed this history first, and the rollback did it did its thing after that. But it could happen that the rollback is restoring the old delete marked records as they were after the first transaction. If the purge view wasn't updated yet, well, there could be, hypothetically, if it was a more complex example, there could be other transactions that hold read views that prevent the purge from running. Or it could be that the system is overloaded and the purge thread didn't get a chance to run yet. So we could get this situation that after the rollback, we still have the delete marked record and purge will remove them. Now, if the purge view was advanced, but purge didn't yet process these records, that's also a possibility. It got the permission to remove history, but it didn't actually start removing yet, or didn't get to this table or this undo log record yet. It can happen that rollback must do the purging itself. So in this case, it starts again from the secondary index record. It removes the record. And sorry, this is about the purge itself. Sorry, I was misreading. So now we assume that the rollback completed, and then is the turn of the purge to clean up. So the rollback completed, and now we got the purge that will take care of the first transaction. So also the purge will remove records from the secondary indexes first, and last step is removing the clustered index record. And now after both the rollback and purge have completed, we end up with an empty table and everybody is happy. But it's not that simple. There are more complex cases when if you are updating a secondary index or an index column back and forth between the same values, then it is possible that rollback will determine that, okay, it's not safe to remove this secondary index record. I have to delete mark the secondary index record instead. And purge, because the transaction was rolled back, purge will not get the undo log record for that at all. Rollback will delete the undo log record because it is supposed to roll back everything. So purge will not see the record. The delete marked garbage will remain in the secondary indexes. There's a bug for that, this MDev that was recently filed as part of a finding that was made when I implemented an extended check table in MariaDB 10.6.11. This extended attribute was ignored by InnoDB until this recent improvement. So it actually got the one old regression and then this even older bug that I think is present also in MySQL. So for the last part of my talk, I will explain a bit how this check table in InnoDB works. It always computes the number of rows in each index according to the current read view, and then it will report any mismatching counts. Typically, if you have fewer records in secondary indexes than in the clustered index, then you have that is a corrupted secondary index, and the secondary index will be flagged as corrupted, and further use of that secondary index will be disallowed. Because MBCC is kind of filtering the extra records of the secondary indexes, it cannot really report more records in the secondary index than in the clustered index. So it cannot actually complain about those extra secondary index records by simple counting. And in addition to this counting, we are also checking that the keys are stored in the right order, like in the ascending or descending, whatever is defined for the columns. In the beginning, InnoDB didn't implement any check table attributes. In MySQL 5.5.35, this quick attribute was first put into use. So if you specify that, then InnoDB will skip the validation of upper level V3 pages, like the previous and next links between pages and the child and parent links. And it will also skip the validation of the InnoDB adaptive hash index. That is a global index, kind of a subset of index pages that are in the buffer pool. So that adaptive hash index validation will actually be run for all tables in the buffer pool instead of the table that check table is supposed to check. And this extended check, basically it will allow to find orphan secondary index records. How that works? Well, it's a completely rewritten code based on the old code, but just doing the necessary steps, nothing more. But there are also some additional checks that are not done by the normal MPCC code path. So we have some special reporting of records or pages that have a two new transaction ID. That would indicate that the undo logs are corrupted in some way. And for cluster index, we are reporting records whose history should have been purged. That is not a hard error, it's just a warning. Because if you upgrade it from an older version than MariaDB 10.3, then you could have transaction IDs fields being non-zero after an insert, and they were not reset. So it will not cause the table to be flagged as corrupted, but it's a warning that you have some garbage in your table and maybe you should run optimized table. For secondary indexes, this extended check does some extra work. It's actually doing this clustered index record version lookup for each record that we find in the secondary index. And if we find a secondary index record that is not delete marked and it doesn't have a corresponding version in the cluster index, then we complain and we flag the secondary index as corrupted. We have had some cases where we got some crashes, mostly related to indexed virtual columns, where we rather easily got this form of corruption because of bugs. There were some bug fixes already in MariaDB 10.6.10 that we don't crash so easily on corrupted pages. But that was the main motivation of implementing this extended check, that you can actually detect this very harmful corruption in the secondary indexes. We also detect delete marked secondary index records, but we don't flag the index as corrupted. It is kind of harmless garbage because the MBCC logic can deal with that. And even in this extended check, we are counting the records according to the current read view. So this iteration will, on the secondary indexes will both find all versions that are reachable, haven't been purged yet, and at the same time it will also count the exact version that corresponds to the current read view. And that, I think, allows us to detect the missing secondary index records. Yeah, that was basically what I wanted to say. Yeah, it was the last slide. So I'm happy to answer any questions.
So any plans to add also checksums of the key values and the primary keys to ensure that they all actually fit together?
Yes, that would be a possible further optimization. Definitely worth considering. But
this is really great that this is finally done. I wanted this for years and years and years.
Yeah, it's making our life easier when we can detect more corruption during our internal testing.
How about repair? If you notice that the index is corrupted, how can we repair it?
Well, for secondary indexes, it is easy if you have extra records, but the table space itself is not really corrupted. You can drop the secondary indexes and create them.
But
or
if you can't repair table like that, do that automatically because it sees this is marked crashed. Then we just recreate it.
Well, for InnoDB there is no repair table yet. I think repair would make sense for the cluster index if you have some corrupted pages in the cluster index and or you have some broken links between cluster index pages. Like for example, if somebody did this popular thing that if you have a recovery problem, just delete the InnoDB redo log, and then it will not complain in recovery. Instead, you will get a corrupted database, but you will not notice it because you don't. You have so many tables, you don't care. It will crash sometime later, and then you complain that InnoDB is crashing on a corrupted page. So for that case, I think it would make sense to have a repair. That it would require a different algorithm. You would try to find to correct the pages inside the table space. I think it's definitely worth considering or implementing, but it's not in. There are some higher priority things to do first, I think.
Just adding the pairs to notice we had a flagged index. Drop it and recreate all those. That should be trivial with the current code.
Yes, it's mostly an SQL layer thing. If somebody can implement the necessary parts on the SQL layer, it's rather trivial to do the interface for InnoDB side.
Marco, we have a question from the audience from Jean-Francois. Isn't there already a checksum on InnoDB pages? What would a checksum on a row add? This is in relation to Monty's question.
Yeah, it's true. There are page checksums, but page checksums are only computed when a page is written out from the buffer pool to the data file. So it's not exactly the same thing. Maybe Monty can explain this checksum thing better. I think it's part of a check table quick in area and MyISM.
Yeah, so but at least area we had also the option to have a checksum per row. That's mostly for debugging to see if something goes wrong. But that's an option to have that, and actually user level. But the idea with the checksum is that when you scan, basically normally check works by, at least in those MySQL engines, that first we scan the rows, in this case the clustered index, and then we also calculate the checksum for each key. And then we scan the keys, and then we check that is the checksum over all the key values the same as in the as we got from the rows, and then we know that they will probably match.
Okay, so it's like, for example, just on the primary key column values, not
and also for the keys, because you can create the keys from the row, so you can then you do a checksum.
For each pair, like if you have an index on column B and primary key on column A, then you will compute a checksum on these A-B pairs.
And actually, you only, or only on A. If let's say on all key parts, I will do a checksum, and then I will ensure that the key has the same checksum. And then you can also have a checksum of the primary key separately to see that is the first part correct and the second part correct.
Okay, I think in that case you would have to do some sorting or use a special checksum algorithm that if you are adding things to the checksum in a different order, then you
just use plus. Checksum for each things, and you just plus them.
A simple sum, yes, that would work, but something like CRC wouldn't work.
You do CRC on each key value, and then you do plus them together. That works.
Yes, if you are like summing some.
Just an extra easy check that doesn't take much time.
Yeah, except that we have this extra time that may be needed on the secondary indexes if you have to do the MVCC lookup. Yeah, but if the table hasn't been changed for a long time, then you don't have to do that lookup. So it definitely would make sense in some cases.
So follow-up question from Jean-François. So a checksum on a row would allow to detect a bit flip before the page is flushed, right? Preventing flushing crap.
Yeah, but how much overhead would that create? It's
the question. I don't see a problem with overhead. That's something that you can just add when you have problems. If you have a problem with the hardware or something else, then you add it.
Yeah, sure, but if we have an option to add per row checksums in the database, then that would be additional overhead to check if that option is enabled and so on. So I'm not too keen to do that, but
we only have to check that at check table. So it is basically only have a small overhead on insert.
Yes, it could be done, but I'm not too keen to do that. Actually, maybe it could be done as a virtual stored column. Then it would be a matter of the SQL layer to validate that kind of...
You send all the problems back to me, thank you.
Yes, I'm trying to keep it simple at the low level.
We don't have any more questions from the audience yet. So if there's any other questions from... Marco, maybe you would like to share a little bit more about the roadmap of InnoDB, since we still have a few more minutes, discuss some upcoming feature.
Well, now that MariaDB is moving to the stock exchange with this SPAC deal, I am bound by some whatever Sarbanes-Oxley Act or thing like forward-looking statement. I have to be careful. Let's see. At least one thing that we have been actively discussing in the near past is a ticket about not releasing page latches so often. For example, in an update or delete statement, currently it's done in two phases. There's a locking select, and then the page latch will be released, and then the SQL layer will tell that, okay, I got this key from your select, please delete it or please update it. And then InnoDB will acquire the page latch again. And that's a kind of waste of time. And there is also, as a workaround to this overhead, there is a prefetch cache inside InnoDB that if it notices that the SQL layer is fetching 4 or more subsequent rows from an index, then it will start prefetching. It will fetch 8 rows. And all that could be removed if we make some changes to the SQL layer so that we will retain the page latch. Actually, we don't even need to create an explicit lock on the record when we are doing this locking read, because we could use implicit locking for the delete and update. Those delete and update would simply update the record and put their transaction ID there. We wouldn't need to create an extra lock before they get to that phase, because it would be protected by the page latch. So that is definitely one thing that I want to have in the near future. It's more up to Sergey Galuchik and the optimizer team to implement some corner cases which are causing trouble for that.
Okay, thank you.
Well, thank you, Parko, for the MVCC overview. Very good presentation. Thanks.
Thank you.
So, welcome to the last scheduled presentation today. There will be, if there's enough applause of this one, there might be an encore presentation. And this one is by Andrew Hutchings. It's about contributions to MariaDB contributing code. We already mentioned at the beginning of the presentation by Daniel Black that we have two presentations where we said that, well, he presented a couple of special cases or instances, and now we're for the generics. So Chief Contribution Officer Andrew, go right ahead.
Thank you very much. As Kai said, I am Andrew Hutchings. I'm known everywhere as Linux Jedi, and I'm the Chief Contributions Officer for MariaDB Foundation. Now, that's a little bit of an odd job title, I know. My background is I worked on open source software for a very long time, including MySQL. I've worked for the MariaDB Corporation for a little bit, and now I'm at the MariaDB Foundation. I've also worked on several other high-profile open source software. So my background is quite vast, and I try and bring all this into my role here. Now, Kai mentioned before, the three pillars of the MariaDB Foundation are openness, adoption, and continuity. And I like to think that my role kind of blends into all of them in some way. So part of my role is I aim to make the contribution process into MariaDB Server as easy as it can be. And that kind of falls a little bit into the continuity part. And I'm trying to reduce the time between a pull request into MariaDB Server being opened and it getting closed, either through merging or some other reason. But not at the cost of kind of the quality or the community communication for the given pull request. I create the contribution metrics for MariaDB Server, and that kind of falls into the openness side of things. And I also try and work with open source communities and the distributions, etc., to try and improve MariaDB for them. So that kind of falls a little bit into the adoption umbrella. So I want to give some examples of the type of contributions, because everyone, when they hear contributions, thinks code contributions. And some of the other ones have actually been discussed today, such as funding. So Soren's field is more to deal with the funding side of things, but funding MariaDB Foundation helps us grow the community around the project. So every little bit it helps there. Then we've got documentation. So that's more Ian at the Foundation's forte, but the more the documentation improves, the easier it is for people to adopt and use the project. As far as community goes, we have quite a vast community in lots and lots of different places. So Zulip is our main kind of live access thing. We have the mailing lists. There are also Reddit groups. There's all sorts of different places. There's a community Slack as well that's owned by the corporation, but we're also there. So we in the Foundation cannot be everywhere all at once. So helping out with community questions is another great way of contributing to MariaDB, even if it's not in code. Translations is a fantastic way to contribute. So was part of the English education system, and we are not taught languages very well. My wife is actually first language Welsh. I actually lived there for 4 years, and I still cannot speak barely a word of it, So I'm not very good at the translation thing. We always need help there, because there are always new error messages coming in, new different messages coming into MariaDB Server that need translating. And also, we'd like, eventually, parts of the knowledge base to be translated into many different languages to make it easier to adopt. Then, of course, you've got usage, bug reports, feature requests, etc. Using MariaDB itself, especially the newer versions that are coming out, and giving us feedback on that really helps us out, because we know what we're getting right, we know what we're getting wrong, we know what is broken, so that when we get to the LTS releases, we know that everything is as nice and stable as it can be. So I want to talk about one case in particular, which is Intel. Intel makes some great non-code contributions to MariaDB Server. They do provide some code where they can as well, but it's a little bit difficult for them for various kind of legal kind of reasons that I won't get into. But various things they do for us, like they constantly benchmark and test various versions of MariaDB and are feeding back information to us. And I believe a case has already been brought up today of where there was an issue where there was a potential regression in a future version of MariaDB, and Intel found it, fed back information, told us roughly how to fix it, and we fixed it based on that. They supply us with hardware, so we can test things against the latest hardware. It makes part of our BuildBot system. They provide financial assistance to the MariaDB Foundation, and Steve Shaw from Intel is part of the board of the MariaDB Foundation. So there are many different ways that Intel are contributing that aren't necessarily just throwing code over the wall to us. So there'll always be things you can help with, even if it's not just with code. Now, why contributions are important, it gives us a much more diverse input from a range of life experiences. So if you've got just one company contributing to a code base and everyone lives in the US, you're not really meeting the use cases necessarily of people in Europe or in Asia, etc. So getting lots of contributions from different companies, different people, you get a much more broad feature set, you get a much more broad use case. The project goes in the direction that the users want, not necessarily led by just one individual company, which I think is fantastic. Sometimes marketing-led things can go where chasing the money for that company and not necessarily what the general open source user who's installing off a Debian distro actually wants. And it means that you can fix things that are important to you if you want to contribute bug fixes. So sometimes there are paper-cut bugs, usually low-hanging fruit kind of things that in many projects just get ignored because they're not high monetary value for the company that's actually writing or coding the project. But it could be important to you and you know how to fix it. So, you know, or at least filing a bug report and giving us more attention to it so that we know it's there. We can actually fix it and we're not as incentivized kind of marketing-wise to do otherwise, if you see what I mean. And it's building a real community around a project. Not really much else I can say about that. You know, having quite a diverse group of people contributing means it's quite a wide community. Another part of my role, as I discussed, is metrics. So at the moment, I've implemented 2 different ways of collecting metrics on contributions so far. There'll be a lot more coming, and I'll discuss a little bit of that later on. The first of all is collecting metrics from Git itself, from the Git log, using something called GitDM, which stands for Git Data Miner. It was a project designed for the Linux kernel tree. We've modified it a little bit to suit our needs better. For example, it was designed to mine the entire kernel tree, every single branch, etc., which doesn't suit our needs so well because we have a lot of feature branches that are in development that might not actually make merging, might actually be merged in the future, etc. So we just kind of filter out anything but the branches that we want to focus on. So 10.3, 10.4, 10.5, 10.6, 10, up to the latest branch. We also deliberately filter by date ranges so that I generate reports based on years. So the 1st of Jan to 31st of December on any given year, but we can actually generate based on any date range you want quite easily due to a script I wrapped around it. I've added a contributor account per organization. This was a suggestion by Otto from Amazon, in fact. So while we're generating reports for individuals and organizations, there is also a contributor account for that organization saying how many contributors came from, say, MariaDB Foundation, MariaDB Corporation, Amazon, etc. And a group organization by type of organization. So everyone who is a distribution, such as OpenBSD, FreeBSD, etc., they're all grouped together. Everyone who is a sponsor of MariaDB Foundation is grouped together, and things like that. And then there's an other bucket for everyone else. So the moment that's done via a script afterwards, rather than the modification to GitDM, that can cause issues when someone moves organization from one place to another. But that's something we want to kind of incorporate into GitDM in the future. And that way it'll be a much more accurate response. So I actually keep in all this is open source. You can actually go to the metrics repo, get all this now. It has the configuration of who we figured out what works for which company, etc. We also have pull request metrics. So this is almost a benchmark of me in a way. We use the GitHub API to get the amount of total open pull requests, in any given week, the amount of new open ones, new closed ones, and new merged ones. So you give it a week number and it will generate that report. It takes a little bit of time to do it because we're rate limited on the GitHub API, but I made a few tricks to cut down the amount of requests needed. So I think it's only about 6 requests per week you need to do now or something like that. So talking a bit about metrics, I want to talk about an anecdote which will come clear in a minute. I worked on a project called Drizzle. It started out life in Sun Microsystems as a fork of MySQL. I was a contributor there, but not at Sun, but not a main contributor. It was kind of a side thing while I was there. I eventually became an employee working for it. In 2009, the Drizzle project had a goal of 50% of the contributions should come from outside of Sun Microsystems. In 2010, 100% of the contributions were outside of Sun because Oracle fired everyone. Rackspace then acquired them and it continued on, but it met the goal. But the point is, joking aside, it's great to have a high percentage of contributors outside of the organization rather than internal. In 2022 so far, there are 35 contributors in the MariaDB Corporation, 8 in the MariaDB Foundation, and 65 outside of the MariaDB Circle. Obviously, these 65 are not producing anywhere like as much code, but it's great that we're getting this kind of diverse contribution metric. And there's actually similar statistics in 2019 as well. Something happened in 2020, can't think what, but it did cause the external statistics to kind of drop a little bit. I say most contributions still come from the MariaDB Corporation as far as actual code goes. So I can actually show you a little kind of summarized view here. As I said, in 2019, 2020, we got around 36. So the number of contributors from MariaDB Corporation and MariaDB Foundation stay pretty much static. But you can see we've had consistently a pretty high number, almost more than both combined every single year for the last 4 years. So it's pretty good. And 2022, I know we have some open pull requests right now by brand new contributors that have come in the last couple of weeks. So I expect that 65 to be even higher by the end of the year. And if we dive a little bit more into contribution metrics for 2022 so far, this is where you can see where the actual commits are coming in here. So even though MariaDB Corporation has 35 hackers, they've given 1,688 commits, nearly 500,000 lines of code added. I have to separate lines of added removed here because the way Git logs things, a change is a line removed and then added. So, but you could also just remove lines or just add lines. So I separate out lines added and removed. And it does actually mean that we've had more contributions from other contributors this year than we have the MariaDB Foundation, even though the Foundation has full-time staff working on MariaDB Server. So the final metric, this is going to be quite difficult to see here, but this is the open pull request metric. The bottom of the y-axis is, you can see the number there is 80. So it doesn't go all the way down to 0, otherwise this would be a much taller chart. I joined at the first large peak there, and my goal has been trying to get it down, but I haven't gone and just closed everything. I've been talking to people, trying to get pull requests either moving along, or if it's in a really bad state and we can't get hold of the contributor, I have eventually been closing them, but saying, feel free to reopen this if you want to continue with this contribution, because, we think it might be a good idea. So things started dipping down. I got really sick last month, so things started climbing again, but I was in hospital a little bit. And then I've been preparing for this, so things have kind of stagnated a bit, but I hope to start the decline again over the next month or so, and hopefully we can get it down. So right now, I think there's just over 100 open pull requests, and it peaked at nearly 120 at one point. So it's progress. It's not where I want it to be, but it is progress. So talking about the metrics future, I want there to be, and actually this is something that was brought up in a MariaDB Foundation board meeting. I want it to be a breakdown of Git contributions by module and engine, for example. So we know which corporations, which people are contributing to, say, InnoDB, Connect Engine, Spider, etc. So, sorry, a lot of background noise over there. So we know who's contributing to what kind of thing. This was something that was brought up by the board. It will require probably a larger modification to Git DM, but some of the framework there is already there to do it. Certainly the Git log already has this, so Git DM should be able to filter it. We should be able to do this without too much difficulty. I want to log the average time to merge pull requests, probably both median and mean, because to start with, it's going to look quite messy because we will have a few that are merged and closed within days, and then we have a few that are merged and closed within 4 years. So trying to get a balance there at least kind of over the next couple of months is going to be a bit messy, but it's something I should log along with these kind of charts. And then we want to merge these metrics into everything else, such as the metrics we already get on downloads and things like that. So we want all this. At the moment, it's in lots of different places. There are community metrics as well on like forum posts and things like that, or mailing list posts. We could get Reddit, etc. So we can collate all this in one place and have a really diverse set of metrics that's consumable and really show what the MariaDB Foundation is doing for everybody. And if there's any other metrics you want to see that we aren't doing yet, feel free to contact us, let us know, or contact me. This is how we got the kind of hack account in the Git commit metrics. Was Otto mentioned it in a comment, and I thought that was a great idea, so we did it. It only took a couple of hours for me to implement. So now I want to talk a bit about how to contribute code. I wrote a blog post about this, which you should totally check out. I'm going to summarize it a little bit here, but there's some basic steps to follow. And if you follow these steps, it helps reduce the round trip time between you opening a pull request and review, because there could be multiple back and forths. And it helps us to stop rejecting things that we could never possibly accept, because I hate when we have to do that. You know, people have put time and effort in, and it's just not going to fit, or it's already being done somewhere else, and you weren't aware that it was being done somewhere else. So there's some basic steps to follow. Step one, talk to us. Before you even start anything else, talk to us. We can guide you, we can help you with every step of the way. The MariaDB team are approachable via Jira and Zoomlip. I'm approachable. In particular, Vincenzo, Daniel, and me. Kai called us the three musketeers of the MariaDB Foundation. You can talk to us particularly about any level of technical thing. I've got quite a diverse technical experience. I was the lead of the column store team at one point, so even though what I'm doing here today is quite high level, I do have technical knowledge where I can help out. Tell us what you want to work on. And we can say, yeah, that's excellent. If not, we can say, yeah, maybe you want to think about doing it this way. You know, there could be things you haven't thought about yet that we can help you out with, angles you haven't thought of. If you don't know what to work on, then take a look at Jira and look for the beginner-friendly tag. These are Jira tickets that we've decided are going to be quite easy to pick up and start if you've never coded for MariaDB before. And again, we can walk you through this and how to work on them if you don't know yet. And if there isn't a Jira ticket for what you want to work on, feel free to open one. Again, this helps us track things. Step two, code it up, write some code. Against the oldest affected release, if it's a bug release, or against the newest development version for new features. This helps us, otherwise we've got to rebase it against those particular versions. Please stick to the same coding standards around surrounding code. You'll find that every storage engine probably has a different coding standard. The coding standards aren't well documented yet. This is something I'm working on. There's actually a pull request open right now for a coding standards document, which at least documents the basic MariaDB server code base, but there is more we could do there. And there are some engines that don't connect engine, which I particularly work on. It's not a great example because it mixes tabs and spaces a bit and things like that, but there's stuff we could clear up there. And but in general, try and keep to the same coding standards that you can see around things. Add test cases. Test cases are really important, not only because it makes sure that the code does what you says it does, but also it makes sure that someone doesn't commit something that's going to break what you did a year down the line. Run the MTR test suite locally. It makes sure that there's nothing that your code change breaks. It's very possible that you change one thing and it breaks something over here that you weren't expecting. And you could just use BuildBot to do that, but then that eats BuildBot resources. So running it locally first at least is a first check to make sure everything's good before you actually open the pull request. And if it's a feature, please write some documentation in the Jira ticket. I know Ian will thank you very much, Lee, for having documentation that he can literally copy and paste into knowledge base when it's ready. Step 3, open a pull request. A form will pop up when you do this in Markdown. Filling this in will help us triage the pull request and fill out and figure out the intention of the pull request a lot easier. If it's your first time opening a pull request, a CLA assistant will pop up and say, please sign the CLA. You can click through this and sign the CLA. It will give you the documentation. You can click through and it will also ask you if you want to use the 3-clause BSD instead. Or if you just want to contribute under the 3-clause BSD license, if you just declare that as a comment in the pull request, we can then accept it. BuildBot will run as soon as you open the pull request. Some of the builders will report directly to GitHub. Some of them are actually blocking. We won't be able to merge until they're actually green. So take a look what BuildBot reports. If it reports one as red, take a look as to why. We'll actually do a more in-depth look at BuildBot before the code is actually, as part of the review process, because there might be some esoteric builders that actually fail in weird ways, and we can actually point you to these. Step 4 is the code review. So MariaDB Foundation and Corporation engineers will actually review the code and give you feedback and advice. If we think the code is ready, we'll approve and merge it. Community members are also welcome to review and comment on the code. And it's another way you can contribute. They won't be a approver, as in they can tick it and then it gets merged. But their feedback actually helps us because they might spot something we miss. Reviewers miss things sometimes. And if we're taking our time to review a pull request, we're dropping the ball, tag me at Linux Jedi in it, and I will try and get it escalated. We've got quite a large backlog right now, so it's very easy to miss things. And it might not be me or anyone in the foundation reviewing it. If it's an MariaDB thing, I may be able to get Paul Marco in to review it or something like that. But we'll be able to pull in the right kind of people to review your pull request. And that is all I have. So, questions?
I was just wondering, does it happen often that somebody contributes a pull request and then there is review input and they just don't react to it, or just don't either not have the time or capacity or desire to sort of come up, bring a pull request up to the standard?
Okay, so yeah, if someone contributes something but they don't have the time to bring it up to standard based on the feedback, because there's 2 different ways you go there. If they just completely blank us after that, which can happen for a variety of reasons. They might have moved on to a different company and it was a corporate contribution or whatever. In that case, and I think in the case where they don't have the time, then we can get, and we have done this before, we get MariaDB engineers to take that commit and then add commits after that to clean up the pull request ready for merging. We've done that quite recently for some Debian changes that were almost ready but needed to fix some issues with RPM packaging. So we can add, so your contribution's still there, it's still tagged as you, you'll still be in the metrics, but we'd also add additional commits to fix things up.
Yeah, and I'd like to add that we even get ideas of features from contributions that don't get initially merged.
That is true.
So we actually have one engineer now, Manuel, working on aliases for MySQL client. And that was a contribution from back in 2016, I think. It wasn't ready. We didn't get time to merge it. Eventually, the pull request was closed, but we didn't abandon the idea. So even if your code is not complete, it's still worth getting us to look at it.
Absolutely. And like I say, it is the whole thing I said before about, talking to us, keeping the dialogue open, and if you're in over your head, definitely talk to us. We can help you out in one way or another, particularly at the foundation, but also we can pull in corporation resources if need be, if it's something that they are interested in as well.
So Andrew, do you have questions for somebody in this audience?
That's a really good question. What would you like to see from us? Honestly, we need feedback on the process. So I don't know if we haven't got any external contributors yet in the audience. But certainly from the wider audience, if there is part of the process that you think needs improving, let us know. There are things that I definitely want to get improved. I know the CLA process right now is not great, and we know this, and we have some background work going on to improve this. There are several other things as well I can think of, such as the review process. We can tighten things up with a formalization of processes and things like that. So there are definitely things that we need feedback on. I want to know what we're getting wrong and what we're getting right.
And I want to add one more thing. We every year have been part of Google Summer of Code, and a big chunk of the contributions have been submitted by students working during Google Summer of Code. And I think roughly 1 in 5 of these students end up being employed by the corporation or the foundation. Mm-hmm. So you
happen to be one of them.
I happen to be one of them. So I initially contributed roles back in 2013, so that was fun.
Yep.
So if anyone is interested in applying for this, know that Google Summer of Code now is no longer open just for students. It's also open for professionals that have not worked in open source before, and that they might be interested in working for an open source company in the future.
It is a It is a fantastic project. For those who don't know about it, Google essentially pays students, but I guess it's everyday
contributors.
People now,
they call them now,
to actually contribute code for a specific project over the summer. I've been a mentor for it before for 2 different open source projects. And it's a really great thing. It gets people into the industry, and it gets us new contributions that we wouldn't have been able to work on otherwise.
And it's actually quite a big category in your categorizations of lines of code.
Yeah, in the deeper metrics, so I publish metrics quarterly, so the next one will be coming out beginning December-ish. There is a category just for Google Summer of Code contributions because it's big enough to be a category in its own right.
Andrew, would it be of your interest to this idea to offer the best contribution some reward? So,
yes.
Yeah.
That's absolutely something I want to do. So before I joined the MariaDB Foundation, I was at WolfSSL, and I'd actually contributed to WolfSSL before, and they sent me quite randomly a drinking glass branded and some stickers in the post, which I was not expecting at all, but it's a really good thing, and it helps. I think it helps engage dialogue as well. So I definitely I need to talk to Anna about this, but I definitely want some kind of swag to happen for first-time contributors. So I really want to make it happen. Watch this space to see if we can make it happen.
So one other thing we haven't talked about is we also have a HackerOne program where we encourage security researchers to try and break either MariaDB or MariaDB.org. So we currently don't offer swag for those sorts of bug reports, but as Andrew mentioned, that might be on the table. Nevertheless, you still get reputation and you can earn, let's say, credibility within the security space if you submit reports to us.
Absolutely. And HackerOne's a fantastic project. It was started by the ex-CEO of MySQL, so, you know, great stuff there.
Okay, Andrew, thanks a lot. Very, very clear presentation on how to contribute to MariaDB. Thank you. And mind you, this was not the entirely last presentation. That was enough applause for there to be an encore, so stay tuned for us to start real soon.
I think you appreciate not getting that background.
So we had a sufficient number of applause here for us to have an encore presentation, which was not scheduled, and this is accompanied by a glass of wine by most of the audience. Perhaps not the presenter, but you were unsober enough not to use your own name in this presentation. So Brandon Nesterenko is, I know you as Andrei Yelkin. You will talk about global transaction ideas in MariaDB binlog, and you just said that you will have a fast forward, something along the lines of 15 minutes. So go ahead, Brandon.
Thank you. So my name is Andrei Yelkin. I'm a part of the replication team. It's lit. So we few people, but very powerful. We will see. You will see now what we can do. So this presentation is about MySQL binlog. Well, formerly MySQL binlog. That's the name of the unsung hero. We all speak here about how cool the server is, but how about this one? So let us see. The talk was prepared by my colleague, but Brandon is currently must be somewhere through the mountains, through the valleys, somewhere in Colorado. I know that he told me. Maybe he's watching, then I tell him hi. So everybody must know what MySQL binlog is. If he doesn't, then, well, maybe he's doing something else than I imagine what people should do with database. Well, how about I lost my transaction? Yeah, first question. Who didn't ask this question? Yes, of course, MySQL binlog comes to rescue, and yeah, anything that we can improve in it, of course, is welcome by users. And so what's done in this presentation, and we will show, this is awareness of this tool, this powerful tool, used for very different purposes. So it's now become GTID aware. And what it is GTID? GTID is, I love it. I love it, and who doesn't love GTID, that one doesn't love MariaDB, I think. So design is beautiful, and of course I'm speaking about transaction identifier. The father of this design is Christian Nielsen. I should laud him once again for a very great introduction to this to us. So we enjoy it, and we made MySQL binlog. Then to do what? You see, additions were added into 10.8 and in 10.9. First step was to make start and stop of the stream, so control the stream, its end, start and end parts. And second contribution was to filter this stream. So how we can do that? A couple of words here about how this traditional replication works. That's what Brandon depicted. I need to make some words about it. Quite familiar picture, I think, for many of us. And you see here a replica. It's not. It's not something that I myself like to change, so not the familiar slave. It's not an abolition in the making, but it just the corporation decided our blogs to publish with this. But we are free, we all free. Don't you worry. So you see here that stream of data finally reaches the slave here. I should use pointer. Sorry. And the binary log is here. So it is the object of processing by MySQL binlog or MariaDB binlog. It is used for various purposes, as I mentioned. So where is my transaction could be of the concern of DBA. And it also can be this producer of data for another server. So basically, from here to here, from the two servers, we could establish connection, basically doing what normal replication does. So like this one, yeah. So it's also possible configuration. People should be aware of this thing. About GTID, very simple design. Domain ID, just as integer, 4 bytes. Server ID, it's basically can be anything because the only essential part, the sequence number. This is already 8 bytes integer. And the pair, domain ID and sequence number, basically identify transaction universally in the whole universe. For, yeah, from the big explosion to whatever awaits of us. So server ID here is for flexibility. That's what I praised Christian for this part. You can do lots of things with this server ID. But we will not stop here, so I will defer this expansion to the next good time. Yeah, let's us go further. So here is a data stream. Usually, if we will only focus on the GTID part in binlog, we will see these numbers. 1, remember the domain. Third, number 1 is the order in that domain. So just you see, for instance, in the green belt stream, we have 1, 2, 3. So without gaps, sequence numbers go forward. That's how it should be normally. GTID strict mode. Yeah, that is, I'm not sure where it should have been default in some version. Now I don't remember it, but it's good if DBA's users would set up GTID strict mode to be strict. You see 3 sequences here. And design of GTID, again, considers those 3 as logically, it's up to the user again, but in the good sensible approach by the user would be to make data on these three sequences do not overlap, and then they could apply on slave in parallel. Well, that's how binlog, yeah, actually vertically from beginning to the end stretches. It's actually more complicated when transactions from different domains, yeah, from yellow, magenta, green, they could actually twist or what's the word? but you see now what happens to them. Well, at applying, say, on the slave, it doesn't matter. Parallelly would be applied yellow ranges by one set of parallel workers. Magenta would be applied by another set of parallel workers. And green the same. That's about GTID in the binary log. So now coming to the practical part. So start position. No new keyword is introduced, just the same existing for physical file position. Coordinate to start decoding binlog. We introduced just another right-hand side. So it could be a list of GTID specifying position in the binlog in terms of GTID events. The same to the stop and strict mode. Well, it's recommended very much. Also, minus VVV is added for make output more verbose. With details about violating these properties of GTID strict mode. So this is example of correctly, monotonously growing sequence numbers in each sequence, in each domain. You will see, we see that. Here is example when start position is supplied. We see what happens. We see what happens. So at search of each of these 112, 213, 311. This is the start GTIDs. They are found, and each time in each domain's start position is found, the following transaction, say here in magenta, is going into output. So that's, you see, if no stop position is supplied, then the output would go till the end of binlog file. So then the stop position parameter to the MySQL binlog. Well, almost like that, but you see the position now, I should have said that it's excluding the parameter specifies you find in binlog this GTID, and next to it, it goes to output. Yeah, that's very important. That just guarantees that, this binlog knows what is next to what I know. I'm a requester, so I know this. Say, I possess on my side 112. Okay, I supply it a start position. The program searches for it. Yeah, it finds it. Okay, and next to it is what I has not gotten, so I will have it. Stop position is different. It is inclusive. So we stop when we process it. 114 here. And then, yeah, if there are 3 domains, then MySQL binlog would stop after reaching the last of these sequence. Then we could, of course, combine as we do with physical coordinates. Yeah, so we would have these ranges now in the output. Yeah, there is nothing of interest here. Well, so that's all about this, the first contribution to 10.8. Then filtering is, again, what was done about names. These are new key options for the MySQL binlog. They were consciously chosen to reflect the slave side, the slave parameters. We have ways to set up slave to, yeah, like it says here, do domain IDs, ignore domain IDs. That's what slave can be set up to work, how it works with master. So MySQL didn't have this options set, and they were added. They have been added. And so you see that among them, well, do and ignore a domain, it's rather intuitively clear what's going to happen. And those who are familiar with how slave works with them, yeah, should grasp what's coming. And server IDs may be of less importance. Like I said, in the GTID notion, this is an arbitrary parameter that its user could specify its semantics for its own use. Still, slave can be configured to ignore or accept, and so MySQL binlog now is capable to do this also. Then there is example about domain IDs to do, yeah, so that means only only domains, yeah, here green with domain ID 1 and yellow are going to be going into output. The rest, now it's domain 3 not. Ignore, well, it's a reverse, of course, semantics here. So 1 and 3 will not be in the output. And with the server IDs, well, the same basically picture. I will just quickly browse and well, you now all familiar with this introduction, and any question to this part? It's very practical, so people now should just take computer, yeah, launch its database, and
Does it work also with with the reverse option?
I haven't tested. I don't remember if we have tested it. Well, we should have. I think it should. I think it should. No problem with this. Yeah. The thing is that it's semantics of distinct mode should be also observed. That's what I'm not sure, actually. Thank you. Any more question about MySQL binlog? Okay, so Brendan, thank you. When we turning to the second part of presentation, it's going to be very short, but it's. I hope you will see something, and if not, then this is about what already Federico introduced, the cool feature. Actually, he forgot to mention this to MySQL binlog, which is cool to me, not less. So here is a alter replication with the speed of the light. And actually, I'm not exaggerating. And Federico himself improved myself. We actually can be faster. You will see why. It's about alter online. This DDL statement is this option to alter is made for increasing concurrency, and it's done a great job to allow concurrent even update semantics. So update semantics DMLs in parallel is with alter. But slave so far before this work still was subject to, well, vulnerable to big, great actually lags. That's because very clear on this picture. Alter arrived, and by this old standard execution goes on. Finally, it reaches binary logging part, so basically commit of it in a sense, and it's sent. So then you see 2 times of execution in order to be sent to next slaves. Say if you have more slaves in chain, the lag is multiplication of that number of slaves. Yeah, that's -1, of course. Anyway, observation was ugly, and people suffered using various tools with, well, various, of course, luck. But finally, this call of the users was heard, and we entertained ourselves starting maybe from 2016, when this MDEF, it's referred in the below, was introduced. Okay, now we have 2 pages to look. Last year I presented XA replication. So that was a thing I wanted to mention here, because it actually introduced a method to replicate something, some object, say transaction, in parts, by parts. So XA is replicated by prepare and then by completion. And the same logic here is applied for alter. So we just noticed one thing, that when alter arrives and reaches this point, it's a first deterministic point of its execution. After that, you can leave it on its own on any computer. If you reach with the same execution context on the slave would further go down and execute it with the very same results. So we just have to be patient to reach this point. And once we here, we can send it the first part. That start is this alter everywhere on slave. And this is just a matter of microseconds, actually, this part. That's my metaphoric comparison with the speed of the light. So alter goes first at the intent to alter. And then after all this execution, which can last multiple days, it may end up badly. Yeah, it can roll back, and either decision it's okay or not. It's also replicated, but again, slave will learn about decision again with latency. Well, basically because of the transmission only here. What will play a role? So it would still experience the same microsecond delay. But that's a normal case. In what Federico said, that slave can be actually quicker to execute. So we can speak that delay may be, in a way, to think negative. That's what we achieved. It works, this mechanism works with parallel replication. It works in replication in any direction, old to new, new to old. MySQL binlock works. All these crash cases work. So that was very much tedious entertainment with I should thank and maybe this guy who took the most of the brand to implement it. Sachin Satya should deserve a round of applause, please, guys. If you're watching us, thank you. This is a small thing about how it looks in show binlocks events. 2 events you can see start. And the commit here, you see ID2 means sequence number here of GTID. So it has reference to the older sequence number, the oldest GTID, having itself, of course, GTID to identify itself in binlock. Finally, warm words to guys who took part of this implementation, design, testing. A number of people, Marko left, and he was part of the brainstorming. Sergei Golubchik just made, a great review, and which ended up for us having just one session. We're able to control everything. That was a wonderful idea from him. So of course, Alice Shrepa, who tested this work, she was the main tester. Ramesh Sivaraman, Jan Lindström, and Brandon Nesterenko himself as well. We would like to take this opportunity to thank posthumously our comrade Sujata Sivakumar, who also contributed to this work. Thank you.
So thank you, Brandon, and thank you, Andrei. This was a good presentation and a good bonus conclusion. Did you have some comments? Yes.
Would you expose the SQL as well, so you can start an alter and then commit it? So you could control this already on the primary?
You mean to execute start alter and wait for start alter? We were hesitant to implement this.
Please repeat. You didn't have a microphone.
We considered this design, but waived it because thought that it's overcomplicated our purpose, our aim. But maybe it makes sense. It also makes sense, to execute asynchronously. You send alter, and after that, you start watching what it's doing. After that. You can indeed. You can wait for it reaches whatever computers you need, and after that you commit. Or if not, you roll back. You can have this freedom. Basically, it's not difficult to implement. It could be a contribution, Andrew.
So I believe by now, not just the microphone of Andrei is out of batteries, but I think that the audience is as well. Thank you for staying with us for such a long time, and thanks for a great MariaDB Server Fest. Thank you.